Hello, everybody. Welcome to the next level of streaming. This is a talk that I've been excited about bringing a lot of folks on for. I'm doing this in conjunction with the San Francisco Audiophile Society, but I've also got friends from the Atlanta Audio Club and a number of other places that are pulled in. So thank you so much for taking some time this afternoon to hang out with us while we social distance and talk about streaming and DSP and answer some of your questions about Roon in some cases and a lot of the other things that you folks have been sending in. So I'm going to just kind of show you what the way ahead is for us for this afternoon. This is the agenda that I've put together. So in just a few minutes, or in less than a minute, I'm going to bring Leslie on. She is the president of the San Francisco Audiophile Society. She's going to say a few words about our club and then also any announcements for events that are coming up in the short term. So if you're in the Bay Area, you'll want to pay particular attention to that. If not, just hang tight. And then after that, I'm going to run through a case study. And then Mitch Barnett, if I can get him on Skype, is going to join us at 2 o'clock. When we're going to talk about DSP, we'll do some Q&A and then wrap up after that. So thanks for your patience while we get started. And we'll get going. I'm going to hand you over to Leslie right now.
Thanks, David. Hey, this is just so everybody knows, there's a 30-second delay on this. So I'm talking and David's talking, but you're not hearing it for 30 seconds. So it's a little disconcerting, but we're going to make it work. So thanks, everybody, for coming. And I just wanted to say that we've been trying to adapt to the new normal, dealing with the coronavirus, having to stay home. And the first initiative we had was the Friday happy hour. And we've had a good group of people that are coming to the happy hour every week. It's been pretty fun. I think that a lot of people would like it. If you want to just dial in, I think we have just a standard dial-in that actually you're not dialing anymore. What am I saying? We have just a standard click-in, I guess, on Zoom that you can try every week and just pop in, say whatever you're doing. But it's been pretty fun. It's just a pretty casual thing. You can just talk about music that you're finding, any audio specials. The next event we have after this week's event is going to be Michael Fremer. Same type of format, except it's going to be on Zoom, so it's interactive and we can all see each other, which is very different than this. Fremer's going to be on May 2nd, same time. We are also looking for other suggestions for potential speakers that can come virtually and talk to all of us. What's cool about how we're doing this is we can have people speak from all over the world. So it's kind of a neat forum, and frankly, we might just keep this going, and we might even keep the Friday happy hours going. It's been working really well, and it's pretty fun. If anybody does have any music picks or anything that they want to share with the group, we'd love to get that out to everybody. The Friday forum is a really good way to share it, and if things come up there, we also send it out on Muse. Another thing I just wanted to remind everyone, it's a really, really hard time for manufacturers and dealers right now. So anything we could do to support the music community and the audiophile community in general, to keep them solvent through this tough time, we want to try to do that. Okay. I wish I could take your questions right now. Unfortunately, I can't do that. But if you do send in questions, we can try to answer those, or definitely email them to us. Or come on the Friday forums, because I'm always on it. So I think that's all I've got. David will send it back to you.
Great, Leslie, thanks so much. So what I'm going to do right now is start off with kind of a case study. If you are in the San Francisco Audiophile Society or the Atlanta Audio Club earlier this month, I led some talks on streaming kind of in general terms, kind of gave a taxonomy of different types of streaming hardware, streaming software, kind of what you need at a really high level, all that kind of stuff. Hang on a second. Let me mute this. All right, cool. I was getting a little bit of feedback. So I talked about things in general terms. I want to talk about things in more specific terms since I've got a lot of questions since then from folks who really want to know, all right, you told us about kind of the general theory, like specifically what can I do to get started with this streaming stuff right now? So that's what I'm going to be talking about. So there's lots of ways to do it. I've messed around in the past with JRiver. I use Audiovana. I know that there's Den and Hios and DTS Playfi and all kinds of other things that we talked about. But far and away, the best tool that I've used and found for this is Roon from Roon Labs. I talked a little bit about it at my previous talks, but and a lot of you, I think, are using it or have started exploring it a little bit. So the examples I discussed today are going to be fairly specific, not just because I'm a Roon fanboy or whatever else, but because it really is the best solution that I've found so far. I'll talk a little bit about the cost and where that comes from, kind of what some of the justification is. So you got into this audiophile hobby knowing that things aren't free, and so I'm hoping that that's not a major deterrence. I know a lot of us are used to getting software for free. We go to the app store of our favorite phone or laptop, and most of the applications it seems like we can download for free. They're not really free. A lot of them are ad supported, or there's other, maybe they're harvesting your personal information and selling it to make a profit or whatever. I'm not saying that everybody's nefarious, but there's some kind of business model for people doing these things. In some cases, people are just doing it for kind of the fame and notoriety. But if somebody's making a business out of something, there has to be a business model behind that. And so software, even though it kind of feels like it's free for us or we have to deal with some ads, producing quality software is not really free. And the Roon Labs folks do a lot more than just make software. They have a service behind all this stuff. And so I'll talk about some of why you should consider that not being necessarily turned off by that, unless the kind of $10 a month cost really is a hardship for you. If it is, that's tough. All right, and then you'll have to kind of sort that out. But everybody has a different sense of value. But if you can kind of swallow that cost proposition relative to alternatives, I think that you'll find a tremendous amount of value there. The problem, I think, with Roon on the surface is that it looks, when you first install it, a lot like other applications that are either free or very low cost. MediaMonkey, JRiver, Audiovana, Amara, things like that. It looks like that on the surface, but there's a lot more underneath. And so we're going to be digging into that some today in detail. What I would like for you to do is, or what I'd like to do is kind of explain how you can get started with this stuff in the least expensive, lowest cost way first. That way you're not pouring a bunch of money into it, buying a bunch of expensive hardware and software only to find out that this isn't really for you. So kind of the lowest barrier to entry that I can think of is if you have a reasonably decent home network. I talked in my talks before about how having a solid home network is going to be important, a decent internet connection and a solid home network. And what do I mean by a solid home network? I mean that you have ideally very good Wi-Fi or a wired connection available close to wherever your stereo system is located. Or if you've got multiple listening systems in your house, that you've got decent network connectivity to each of those, that you have a reasonably good internet connection. And by that, I think these days probably 24 megabits per second down is a pretty good standard. Latency is a consideration as well for a stable stream. But if you can watch Netflix or Amazon Prime Video or any of these other things at various locations in your house, you probably have enough bandwidth and enough networking for audio. Audio doesn't take nearly as much bandwidth as these other things. And so you're probably in better shape than you think you are. You need to have a reasonably modern desktop PC somewhere on your network, ideally with a wired connection. So something that's an Intel Core i3, i4, or sorry, i3, i5, i7, but even at least an i3 that's running Windows 10 or Mac OS. What are we doing now? I guess Mac OS 10.10 or later would be a good start. So most people have some kind of computer that's in their house that they don't mind leaving on all the time. If you don't, you can buy things like this for not very much money pre-installed with an operating system. Less than $500 is pretty typical. A laptop can work. Challenge with a laptop, of course, is that it's not everybody likes to leave a laptop on all the time. There's a lot going on with a laptop, but that can work if you have a laptop that you don't mind leaving on all the time as well. You need to have one of those, and you need to have a smartphone or a tablet. So most people probably have all of these things: a computer somewhere in their house, a home network, and a laptop or a tablet. What you're missing is a device that you can connect to your audio system to get decent audio to your computer. So a lot of times I've seen people will just connect a desktop computer or a laptop to their audio system, but that compromises the sound in more ways than I'm going to get into here. We talked about some of this before. So you really don't want to do that. You want to have what the signalist folks from AQ Player call a network audio adapter, or I call it a network audio transporter, digital audio transport, something along those lines. So you need this kind of lower noise, solid state, super quiet, lower RFI emission, ideally reasonably well put together device that you can connect to your audio system that won't spoil the sound, but will carry audio from that more powerful computer elsewhere in your house to your audio system. Think of that computer that's elsewhere in your house sort of like a mainframe. You wouldn't want to have a mainframe sitting next to you in your listening room. The mainframe needs to be off in your quote-unquote data center, someplace else in your house. And then you just have a very small computer that's going to be feeding your DAC that's very quiet. So I'm going to walk you through a case study and an example that I've put together just for this event that describes in detail how to build an endpoint from a $25 or $35 computer board that you can get on Amazon and a lot of other places very inexpensively. It needs a 5-volt power supply that you probably have lying around. In my case, I just pulled an old iPod charger out of a drawer and plugged it in. You need a micro SD card that you can pick up for $5 or $6, something like that. So very inexpensive parts, but the performance is quite good. We'll run through that assembly process as a case study. And then I'm going to kind of explain a little bit about what you can do with it after you're done. So once you've got an inexpensive endpoint kind of in every audio system in your house, there are a lot of things that this opened the doors for you to do. You've got this sort of mainframe machine off to the side that can do a lot of heavy duty processing. It's going to uncompress your MP3s or your FLAC, ideally FLAC. It'll handle any kind of format conversion that's necessary. Maybe some DACs in your house support DSD and some don't, but if you want to play a DSD album, you should be able to play it everywhere. So can that more powerful computer handle those format conversions where necessary to be compatible with what the capabilities of each DAC that you have in your house? There are tons and tons of other functions that we can have this centralized heavy-duty computer do once we don't have that system in our listening room and we're not in a place where we're trying to keep it as quiet as possible. It can be in a closet or an office someplace, making as much noise as it wants and providing as much functionality to our system as we can possibly have and enjoy without having to deal with all the noise. All right. So before I get too far into Roon, for those who aren't terribly familiar, I should kind of break down what the components are since I make reference to those in my case study example. Roon Core is a term that's used to describe this sort of mainframe theme that I've been talking about. If you go to Roon's website, you can't just, there's no piece of software that you can download that says that it's Core, which is a little bit confusing. So I'll explain that. There is a Roon desktop application that can function as Core, though I don't recommend that you do that for reasons I'll explain later. There's a Roon server application that you can download for Roon, and that on Windows just hides itself down in the system tray as a background process that has no UI, no user interface. That actually can function as Core. And then Roon has written kind of their own Linux-based operating system called Roon OS, and it runs on their Rock kit as well as the Nucleus hardware platform that they've described, and some other manufacturers distribute similar devices. And that's kind of a third way that you can run Core. But ideally, Core is one of those three pieces of software. Ideally, it's Roon Server or Roon OS. When you're running a system like that, it's typically run in a headless way, so you don't have a keyboard or mouse or a DAC attached to it. It's just off in the corner on your network someplace. And then you interact with it using your smartphone or your tablet, and it plays to one or more dedicated output devices throughout your house. So 3 components. Core is that mainframe thing. Outputs are these little tiny devices like this Raspberry Pi thing I'm going to show you. But there are a lot of other commercially available ones that are really good as well. And then controls are your smartphone or your tablet. There are a couple of other components of Roon that I'll touch on briefly. So Roon has recently added this feature called displays. So if you have a Chromecast or a Google Chromecast compatible television, and there's some other little boxes that will work this way as well, you can enable those to function as a display inside of Roon, and then you can kind of show on your screen a high resolution image of what music's playing. If some songs actually have lyrics that'll scroll by, sort of karaoke style, without the bouncing ball though. So you can have these lyrics showing up on your television. It's kind of nice. Some people like to be able to see what's on, or be able to show other folks in addition to being able to hear them. If you've got a display device anywhere in your listening room or in your home theater environment, you can, for any output, you can associate a display, and you can have multiple displays throughout your house. And you can configure it to come on command, or you can configure it so that every time you play music in that zone, it turns on the display and shows that display output. So it's a kind of a neat feature. A lot of people have asked for that and found it to be helpful. And then there's another deeper tool, and I'll do a separate video on this. It's called an extension manager. So this is a separate device, typically a separate device from Core that runs on your network. It's also headless, and it adds additional functionality to Roon. And this functionality is typically developed by third-party folks. There's a way that you can control Roon from a web browser, for example. If you've got an older tablet or phone that is not powerful enough to run the Roon remote app, you can just open up a web browser, point it at one of these extension manager things that's running the web control tools, and be able to manipulate Roon that way. So there's a lot of other kind of clever functionality that I'm not going to get into here, but extension manager is kind of a separate part of your Roon platform that can live on your network. So each one of these things, core, output, controls, displays, and extension managers, those are separate physical devices, or they should be separate physical devices that live on your home network in different locations, and they all talk to each other over your home network to kind of support that Roon platform and give you the full functionality throughout your house. I really don't know of any other application in the audio space that has this much depth and breadth, and it continues to kind of grow and expand. When I first started messing around with this stuff, displays and extension managers, for example, were not even a thing, and the functionality of Core was vastly smaller. So it's something that's continually being developed, and the range of hardware that's supported is grown dramatically and continues to grow rapidly. But again, minimum bits that you need to get started are an existing desktop computer, a tablet or smartphone, and a USB DAC. That's really kind of it. I see some questions coming in the stream. What I'm going to do now is start my case study. I will still be here. I'll be hiding in the background, and I'll be answering your questions in chat. So just kind of hang with me. But I hope this information is helpful. This gives me a chance to interact with you directly, while I'm also teaching you how to do this case study type of thing. So pay attention to that, but then also feel free to ask questions, and I'll interact with you there. All right, with that started, here we go. Last weekend I did kind of an extended live stream of making a Roon endpoint from a Raspberry Pi, but I'd like to run through that process a little bit more quickly here, just to give you an idea of what this process looks like. The project was to take a Raspberry Pi 3A Plus, which is a $25 kind of small board computer. I'll show you what that looks like in just a minute. To take this $25 computer, flash a micro SD card with the appropriate software, boot it up, and make it into a usable Roon endpoint. In this case, the Roon would talk to this device over Wi-Fi, so over a network connection, a Wi-Fi network connection, and it will stream to an attached USB DAC. There's some advantages to doing this over using a general purpose computer. Chiefly among those is just that the Raspberry Pi is a much lower power, lower noise device. But obviously it's much less cost as well. So it's a great way to kind of get into using Roon's distributed architecture and getting used to the idea of having separate endpoints throughout your house, endpoints that are separate from your core, and that are very, very low noise. So here's what the Raspberry Pi 3A Plus looks like. You can see it's very small. It's maybe a bit larger than a credit card or so. It has a single USB port on one side that we can connect a DAC to. It's a USB, it's not USB 3, it's just USB 2, but that's all we need for audio. It's good for 32-bit 768 kilohertz PCM. It's good for a DSD 512. It's good for all kinds of crazy rates. So we don't really need anything more than that. We have an HDMI port that we can use for debugging, but it's generally not used. As far as I know, Linux doesn't support multi-channel streaming, so we tend not to use that for audio. It's just for troubleshooting. Power inlets here. On the board itself, you can see this little chip that's, maybe you can see, that has a kind of raspberry engraved on it. That's the Wi-Fi chipset. This is the CPU, GPU, not that that matters very much. And then on the bottom, this is where we're going to insert our micro SD memory card. And I think this is a memory chip, but it's not really necessary to know all of that stuff. So, and then there are 40 GPIO header pins that can be used to attach DAC hats. We're not going to get into that for this project, but Hi-Fi Berry, Just Boom, Allo, there are a bunch of different companies that make hats that are compatible with these things that can be quite nice as well if you want kind of an all-in-one network and analog audio out solution. So for this project, I just recommended that folks buy a little simple case. I've got this kind of clamshell looking case here. It's just two pieces that snap together. So I'm going to take the Raspberry Pi and kind of line it up with the slots in the case and press till it clicks, and then pop the cover on top. And that's our Raspberry Pi device. All there is to it. Now that we've got this assembled, the next thing that we're going to want to do is prepare a micro SD card. Micro SD cards, really, really small. There's some pins for contacts on one side, and we don't need a micro SD card of any significant capacity. Even as low as 2 gigabytes will be adequate for a Raspberry Pi, or for a Diet Pi, the operating system we're going to be installing on this. This one's much larger than that. We're going to put Diet Pi as an operating system, and then as part of the boot up process, it's going to download and install Roon Bridge from Roon Labs so that we can use this as an endpoint, and I'll walk you through that configuration process. First step, though, is for me to insert this card into my laptop's card reader. So here we go. Now, the next thing that I recommend, it's not essential, but it's useful, is to go ahead and format that SD card. We don't know what might have been on there before, and I find it's just safer to format it. I recommend a utility from the SD Card Foundation called SD Card Formatter, unimaginatively. Whenever I format a card, I like to put a volume label of none, just to make sure that I know that it's something that's freshly formatted. If I put other things on it, then I'll typically, it'll either get automatically a new volume label or I'll assign one. But if I see a card that's in my collection that just has none, then I know that it's not been used. You can't see this, but I'm getting prompted to put in a password to use the elevated privileges that are required for formatting this device. Kind of a nice feature. You do want to pay attention to the card. If you've got more than one card in your system, make sure that you're formatting the right one. I don't want anybody out there to reformat their thumb drive with their wedding photos of their entire music collection, so pay attention to that. In my case, I know for sure this is the right one. I can match the size and all the rest of that stuff. So just pay attention, be careful. I don't want you to lose your data. All right, SD card is now formatted. So as a next step, I'm going to, we're going to flash the Diet Pi image onto there. For that, we're going to use a tool called Etcher. Let me restart this because I've done this once before. Hang on a second. Insufficient sacrifice to the demo gods. All right, here we go. So Etcher is another free utility you can download. I like to use these settings, so everything turned off except for auto updates. In particular, we need to make sure that we leave auto unmount on success unchecked, because we're going to need to make some modifications to this card before we put it in the Raspberry Pi. So for an image, I've already downloaded the Diet Pi image for this particular Raspberry Pi. You see it's an image that's about 1 gigabyte in size. I'm going to double check and make sure that I've got the right media here. It's that 31.9 gigabyte SD card I showed you. and we'll click flash. It's going to ask me again for a password, which you're not going to see. If you're doing this on Windows, be aware that some antivirus or anti-malware software, hang on a second, may block flashing of the card because we're modifying the boot block. We're not just copying that image file to the micro SD card, we're writing it at a low level in a kind of a bit for bit way that will enable the Raspberry Pi to find the boot block and boot from it. And that process sometimes triggers antivirus software, so just something to be aware of. I'm doing this on a Mac, so I'm not going to see that problem here. This process usually goes pretty quickly, especially if you have a USB 3 card reader, or if you've got a card reader that's internal to your computer that can run. It's on the USB 3 or one of the faster buses in your computer. One thing that's nice about DietPi though is that it is a small, compact operating system, so it's much faster to flash typically than other operating system options that you could run on the Raspberry Pi. Alright, so that is almost finished. Great, that's done. Now that we've flashed the image, we're going to need to make some configuration changes. So let me clear this up here. So what I'm going to do, I know this may look a little bit scary, but I'm running a terminal window on my Mac. If I was on a Windows machine, I would be running a DOS prompt or a command prompt. It's a command line interface. We just have to do a little bit of command line work to get the image that we've put on this card configured so that it will boot up onto our Wi-Fi network. So on Mac, I'm going to cd2/volume/boot. And if you're on a Windows machine, you'd need to figure out what drive letter that micro SD card shows up as. For example, it might be D:, or E:, or F:. You would type, for example, E: in your DOS prompt, and that would drop your kind of DOS prompt into the top level of that micro SD card. On a Mac, we're going to use this cd command change directory command to get to that location. And just to kind of give you an idea of what's there, I'm just going to take a look at all the .txt files that are there. If you're on a Windows machine, you type dir and then star.txt, you'd get similar kind of output. I want to draw your attention to this dietpi.txt file and this dietpi-wifi.txt file. We're going to be making some modifications to those so that when this Raspberry Pi boots this card for the first time, it shows up on our Wi-Fi network. In order to get it on our Wi-Fi network, we need to tell it what our Wi-Fi network's name is and what the password is, and there are some other parameters that we'll have to set as well. Now, we could edit these files by hand. Let's take a look at what's in these files. You can see there's a whole bunch of what we call key value pairs. There's a name and then a value that's set there. We could edit this file by hand, but as you can see, it's not very much fun to edit all those things, and you have to get everything just right or it won't boot up correctly. So I've written a script that will edit this file for us after asking us a few simple questions. The script is written in a language called Perl. On Windows, you'll have to install an application called Strawberry Perl to run the script. On Mac OS, Perl comes installed by default. So I'm just going to type Perl. Well, first we need to download that script. So that script is accessible from ws-e.com/dietpi-setup. You could download it in a browser if you wanted to, or both Windows and the Mac come with this utility called curl. So you can type this simple command here, curl-LO dietpi-setup. This is the file that we're going to save it as, and this is the address where we get it from. And that will go ahead and download that script for us. Now we can type perl dietpi-setup, and we're just going to get answers to a few questions here. It says that it's going to modify the dietpi.txt. It's actually going to modify dietpi-wifi.txt as well if we have a Wi-Fi network. Let's give this thing a name. I'm going to call it Roon -RPI3A, since that's the kind of thing this is. You can come up with any name that you want. I would try to make it short, and only letters, numbers, and dashes are required. I'm going to say yes, that we do have a Wi-Fi network. In my case, my Wi-Fi network is, for guests, Audiophiles. And the password, of course, is Roon Rocks. And the script is then going to tell us what configuration parameters it modified. We can see here that it's installing application ID number 1 and 121. You don't need to worry about these numbers too much, but I'll just explain quickly that 5 is the ALSA utilities for Linux. It's something that provides us with some command line utilities for debugging sound card issues if we need them. It's just nice to have. 121, though, most importantly, is the Roon Bridge application that will allow our Raspberry Pi to show up on the network and be visible to our Roon core. You can see that we've got our hostname set here. Another important parameter is the time zone. I've written the script so that it tries to guess what your time zone is, so it should put a value in there that is appropriate to you. It's important to get the time zone right because the Wi-Fi radio frequencies and bands that are allowed in different countries tend to vary, and so the Wi-Fi system may not come up correctly and may not use the right frequency bands if this time zone is not set correctly. I believe that's the parameter that governs that. And then we've got our Wi-Fi password and SSID. I'm going to get out of this directory now and eject the card. If I didn't use this change directory command to get out of here, then I would get an error message from the operating system saying, hey, the device is busy, I'm not going to let you get out. I'm opening, you can't see it here, but I'm opening up Finder under Locations. I'm looking for boot, and I'm going to click the eject button. It's just like a triangle with a line under it. And that has cleanly ejected the card. It's important to do that because we want to make sure that the changes that we wrote to the card for that configuration have been flushed out to the card. So at this point, I'm going to remove the SD card from my card reader and put it in the Raspberry Pi. Again, we want to make sure this is installed in the right way. The pins, the gold pins here, need to face the green motherboard, so it kind of goes upside down. This is the Raspberry Pi held right side up. This is upside down. So we want those pins to face the Raspberry Pi. And we should see the label when we're holding the Raspberry Pi upside down. If it doesn't go in smoothly and easily, then you may have it turned the other way. Don't force it, just gently pull it back out and switch it around. So now we've completed the Raspberry Pi's assembly and put the card in. I'm going to get it's not necessary that you do this, but I'm going to get an HDMI cable and connect it so that we can watch what this thing does when it boots up. And I'm going to get a power supply. In this case, I'm just using a little iPad charger or iPod charger. It's just something that I had lying around the house, but it works okay for this particular device. So I'm going to plug it in, and let's switch over to a screen so we can see if it boots up. So if you had a display connected when you connect power, you should see those 4 raspberries at the top, and you should see some messages. Don't get hung up in details about what all those messages are saying. This first step, though, takes a while. This is Diet Pi working out how much space is available on the micro SD card and then expanding the file system to use all of that space. So by default, Diet Pi assumes that you only have a 2 gigabyte SD card, just so that you can use the smallest card available. But on first boot, the first thing it does is try to figure out how much space is available and expand the file system to use all of that space. After that, it's going to connect up to the network, and it's going to update itself. So just like any other operating system that you've installed, after you download the operating system image from the manufacturer or get it out of the whatever installation media you have, there's always going to be a bunch of updates that need to be installed afterwards. And this update process tends to take the longest part of getting this thing set up. Fortunately, there's nothing that we have to do. We just sit here and wait for it to finish. I will say that the Wi-Fi network in my loft is probably the weakest in my house. We have a 4-story house, and the loft and listening room area, which is where I am broadcasting this, is at the very top of that 4-story house. And all of our Wi-Fi signal is sort of beamed downwards so that we get good coverage for the rest of the house. Consequence of that is that the coverage is weakest up here. It's good enough to work with my Roon remotes so that I can control the audio system, but it's not great for this kind of bulk transfer type of work that we're doing here. I'm hoping this gives you an idea of kind of worst case how long this should take. If you've got a stronger Wi-Fi signal when you're setting up one of these Raspberry Pi 3As over Wi-Fi, it should go faster. So at this point, we are going to begin updating the other applications that are on the Raspberry Pi. If I can see, I've got my monitor across the room here, so it's a little tricky to see. Again, if you don't have a display connected to your Raspberry Pi when all this happens, you don't have to. You can just go have a coffee, have dinner. When you come back, if it's not available, then you can do some troubleshooting. In fact, while we're waiting, I'll walk you through some of the troubleshooting steps that I tend to do just to see what's going on if I'm curious or if it seems like it's taking longer than it ought to. So there's an application that you can install on your smartphone called Fing, F-I-N-G. It's a free application. It has ads. I've logged in so that I don't have to deal with the ads, and I'll show you what that looks like. Hang on a second. That's not the right window. There we go. Maybe. There we go. Yeah. So this is my my phone. I'm gonna go and launch Fing, and you always have to press this refresh button in order to get the latest information. So we'll go ahead and let this rescan my Wi-Fi network or my home network to tell me what devices are there. Now I've got a bunch of Raspberry Pis, but you probably don't have as many, or if you do, you can kind of recognize which ones are which. But I happen to know that this one here, this 8.29, that's the Raspberry Pi that we're looking for. With this application, I can do a quick ping test if I want to, which is kind of nice to verify that it's reachable. There are other utilities in here that you can kind of play with as well, but it's nice to just know that the thing is available and working. So it's a useful tool. If for some reason it doesn't seem like it's booting up, if you just want to make sure that it showed up on the network, this is a useful tool. I'll show you some other debugging tips that we can do that require you to know what that IP address is. So for future reference, in here we're going to use this .29 address if we need to log in. Ideally, you won't have to worry about this. The Raspberry Pi should just show up in Roon as an output that you can enable, but if for some reason it doesn't, this is a useful tool for troubleshooting. And when you're doing this DIY stuff, it's good to have troubleshooting tools. All right, let's go back and see if this thing has gotten closer to booting up. Hang on. There we go. All right. Looks like it's running through kind of its final stages of updates. Again, some of the advantages of doing this once you have this stuff set up, this is a very small, very low noise, very low power device that you can set on the floor behind your rack. You can set it in kind of an inconspicuous place. It just needs to be a USB cable's distance away from your DAC, so a meter or so away. I don't know if I would necessarily set it right on top of the DAC, but it's small enough that it can just slip behind. You typically won't have to do anything with this once it gets powered on. It'll just kind of silently run in the background. There are no fans. There are no mechanical discs. There's no mechanical vibrations. It's a very, very quiet, very small device. It does require that you have a switch mode power supply someplace to run it. So if that kind of weirds you out, you could look at doing a 5-volt linear power supply. If that's quieter, you could look at running it off of batteries. I know that some people explore those routes. I've explored that a little bit. I haven't found any significant advantage to doing those things. I played around with using the iPower 5-volt power supply. I'm not sure if that made a significant difference or not. Maybe for a little while I thought maybe it did, but if it was a very, very tiny difference. If you do decide to use an aftermarket power supply, definitely make sure that it's a 5-volt power supply. I have destroyed at least one of these by connecting a 9-volt power supply. And so make sure that it's marked correctly. You want 5 volts, typically 2.5 or 3 amps is plenty of current. Don't do 15. It's easy to get. 15 is the wrong size. So do pay attention to the voltage rating and current rating for aftermarket power supply if you decide to go that route. The power supply that I'm using is 5 volts and then just 1 amp. That's enough to power this little device, but if you're connecting a DAC that is not self-powered, you may need more current for that USB port to operate. It might be a good idea anyway. So Mac manufacturer's recommendations, I think, for the Raspberry Pi 3A Plus are 5 volts and 2.5 amps. For the Raspberry Pi 4, it's 5 volts and 3 amps. So just kind of pay attention to those power ratings. But the 5 volt part is critical to get right. All right, looks like the Raspberry Pi is just finishing up installing our applications, ALSA and Roon Bridge. It's downloading those from kind of the internet. In the case of ALSA, it's downloading from Roon Labs directly. Roon Bridge, Roon Labs controls the distribution of their software, so they want any kind of third-party use of their software to get the code from them. So Diet Pi is doing that properly. And this is the last stage of this final boot. It's going to try to set the clock on the Raspberry Pi to make sure that it's accurate. On my network, it takes about 20 tries for this to work. I'm not really sure why, but it's about done. With any luck. There we go. And we can see the IP address there. It's that 8.29 that we were looking at earlier. So that's the address. We can see that it's come online as expected. So let's go into Roon now and let's enable this output. So we're going to go to Settings, Audio, and you can see I have a bunch of things, but I'm looking for this Roon-RPI3 thing that we just built. It's got to be in here someplace. Oh, and I see that it's not, and do you want to know why? It's not there because we don't have a DAC connected, and Roon wants to see a DAC connected to this thing before it allow us to enable it. So fortunately, I just happen to have a DAC right here. It's just a little self-powered or battery-powered USB DAC. I connect USB cable here, connect USB cable here. Let's get out of this thing. Now, if I was kind of confused about why that wasn't working, I'll show you a little troubleshooting trick that we can do. So if I go back to my terminal window, I can SSH, which is a secure shell login, and this works on Windows as well as Mac. 1.29. Now, if I've logged into this before, SSH is going to try to protect me because it's confused that the security key for this device has changed. Don't worry about that too much. You probably won't run into that. I'm just going to clean my file up here, and we'll SSH in one more time. Accept the new host key, and then the password for this device is Diet Pi, all lowercase. We'll accept the GPL license, and we can see that we're logged in. We've got some nice information here. Tells us what our CPU temperature is. 48 degrees Celsius is a good healthy range for these devices. We've got some suggestions for command line tools that we can run, but we're going to run something that's not listed. It's part of the ALSA tools. It's aplay-l. This will list the audio devices that we have connected. Now, before, our DAC wasn't showing up. If I had our DAC disconnected, or I can power it down, if I ran aplay-l again, it would say no sound cards found. If you see this, then you've got to make sure that your DAC is connected, and make sure that your DAC is powered on, make sure that you've got a good USB cable that's connected properly. There are some DACs that are only compatible by default with USB audio class 1. The Raspberry Pi needs to see a USB audio class 2 device. I know Benchmark and some others that I've seen, I think it's Benchmark, have either dip switch settings, or there are settings in the menu of the DAC that let you choose the USB audio class. I think even my home theater pre-pro from Emotiva, I had to go into the menu settings and change it to use USB audio class 2. 1 was the default. So if your DAC isn't showing up, that could be the reason why as well. If I switch it back on and I run the same command, then we can see that the DAC is visible. If aplay-l doesn't show your DAC, Roon's not going to be able to see your DAC. So it's a useful troubleshooting tip to keep in mind. All right, let's go back to Roon and configure this guy again. So I'm going to go to Settings, Audio, and again we're going to scroll down until we find that, there it is right there. You can't see my mouse pointer, I don't think, but I'm going to line it right up with that Audio tab. It says RPA Roon RPI3A and that 8.29 address, and so I know that's the right one. It's not enabled by default, new outputs aren't, so I'm going to click Enable, and then I'm going to go into Device Setup. So the first thing that you'll want to do, if you have a DAC that is Roon tested or Roon ready, it should show up in here, the manufacturer, and then you can choose which DAC you have. And the nice thing about that is that you'll get an icon that illustrates the DAC as part of the UI. It's a nice feature. You'll also sometimes get a PDF manual that you could open for your DAC that just shows up right in the Roon UI. And then you'll also get a set of configuration properties that Roon is tested and verified to be optimal for your DAC. So it's pretty nice if you have a DAC that's supported. Mine is an iFi DAC, and I can see there's not really anything that matches. So I'm not going to be able to take advantage of those things. So I'll just click out of that. I happen to know that this DAC does native DSD, so I'm going to choose native there. If your DAC does, but it's not native, you might end up using DOP, which is still fine. There's no big deal. It's no problem there. I know that this device is an MQA renderer only. This property seems to be rarely detected correctly, so you may have to change that if you care about MQA at all. For device volume, for volume control, I'm going to use fixed volume because this device has a volume control on it. If you're going to be using your device with a preamplifier or an amplifier or some kind of external volume, a fixed volume is probably what you want as well. In some cases, it's handy to use Roon to control the volume, so just kind of pay attention there. But generally speaking, if you're connecting this to your audio system, fixed volume is what you're going to want to use. I'm going to save this, and then I'm going to go back in here one more time to the advanced settings, and we'll take a look. So 384 kilohertz is right, 32 bits is the sample rate that this DAC likes to use. It detected the DSD capabilities correctly. One thing that I'm going to want to leave MQA core decoder enabled. I think that's a good idea, even if you do have an MQA DAC that supports full decoding. I think the only exception is the Meridian Explorer, which doesn't seem to work very well with the setting, but most DACs are going to work better if you happen to have MQA and you care about that, to leave this on. There's really no downside unless your DAC just doesn't support rendering that you'd want to have that on. So the last change that I'll make is to force the max volume at playback start. Some DACs by default are kind of come up with the volume at about 75% inside of the endpoint. And so if the volume seems like it's kind of soft, just go into this advanced setting and set force max volume, and you won't have that problem anymore. All right, let's get out of settings and take a look at what we have here. I'm going to choose this DAC. This is this Loft iFi DAC. I'm going to click the gear here because we've got a couple more configuration parameters that we can set. It was on here because I had it on from before, but I think by default volume leveling is turned off. I definitely recommend that you turn volume leveling on at the album level. That works extremely well for every case that I've discovered so far. I can go into a ton of detail about why this is important, but just trust me for now and turn it on. If you have loudspeakers in a room, you might want to use a target of 18 LUFS or one of these lower values. If you're using headphones, or if this is just for background music, I found that 14 LUFS, the default as a target, works really well. So now that we've got that on, another setting that if I know that I'm going to be using this thing for headphones, I've got some DSP presets here. But one of my headphones preset just turns this crossfeed DSP on, which is kind of a nice feature. If you don't see that, you can click Add Filter and find it there. There are also kind of cool features, like if you have a specific model of Audi's headphones, you can choose that there and apply an Audi's headphone-specific contour curve. I don't, so I'm going to click out of there. And then finally, let's go find some music to play. This looks kind of nice. Well, I'll go back to this one. And we'll just click play to play a track. Now, if I had headphones plugged in, I would be able to hear what was going on. If you don't like the icon that showed up here, another kind of neat trick, you can edit this zone icon. If your DAC wasn't recommended or recognized, or Roon tested or Roon ready, you can choose kind of whatever's appropriate here. It's getting close to dinner time, so I might choose a knife and fork, but you could choose, for example, kitchen table. If you had this thing in a dining room, if this was your dining room music system, you can modify the icon there, and it just helps family members to be able to quickly identify which zone you have, especially if you've got a lot of zones in your house like I do. Let's take a look at the signal path. I'm going to click on this little star here. We can see that the source is a CD resolution file. Roon is converting that from 16 bits to 64-bit float because it's going to do all of its DSP and any kind of changes in using 64-bit math, which is the most accurate. First thing we're doing is volume leveling, so we're pulling the leveling down. This album's pretty hot. We're doing some crossfeed stereo to binaural DSP to make it sound nicer with headphones. Then we're doing a bit depth conversion again from 64-bit to what the DAC likes to see, which is 32 bits. This might be 24 bits or 16 bits, depending on what kind of DAC you have. And then we're sending it. We want to make sure that this is correct. We're sending this to our Roon RPI3A output. That's the one that I named. If you chose a different name, that's what you'll see here. And then we're going to that iFi audio driver via the ALSA. Describes the technology that we're using there. So that is pretty much all that's involved. If I was doing this with a Raspberry Pi that had an Ethernet connection, I would go through the same process. The only difference is that I would say no to that question about Wi-Fi, and the Raspberry Pi would just boot up using a network connection, a wired network connection instead. There's some advantages to using a wired network connection. In some cases they can sound better. There are fewer drop packets typically. There's less noise in some cases. Certainly there's greater reliability, so I would encourage you to use a wired connection if at all you can, but if you can't, Wi-Fi is a pretty convenient solution, or if you just need the portability and flexibility of doing this over a Wi-Fi connection. Anyway, so that's pretty much all that I had in mind to show you. I hope this has been helpful. All right, so I do hope that was helpful. Gave me a chance to get on the chat and answer a few questions. There are a few more coming in. At this point, or very close to it, I've been hopeful that I could get Mitch Barnett on. He's having some networking difficulties, I guess. We were able to get connected via Skype for maybe half a minute, but with no audio whatsoever, and then his connection just kind of died. That makes me sad because he has a tremendous amount of really useful information to share with you. I'm hopeful still, though, that I can get him back onto the stream later on. So bear with me. There may be a kind of a brief pause or interruption during this part if I'm able to get a stable connection to him. We did make a couple of test calls earlier in the week, and it worked reasonably well. So it could be just kind of gremlins sneaking up on us this weekend. Maybe there's different Wi-Fi interference in his location in Vancouver than normal. Hard to say. It does kind of go back to my point, though, that a Wi-Fi connection is going to tend to be problematic. It's not only for audio, but for video too. If you're an expert at Wi-Fi setup and you have a really solid Wi-Fi environment in your house, you've got very good signal strength, you've got potentially in a larger house multiple Wi-Fi access points that give you broad signal coverage. You don't have too much interference from cell towers or your neighbors' Wi-Fi setups or other places, and you're able to test and verify that. You don't have too much channel overlap in your Wi-Fi signals. There's like a whole kind of science and art to getting Wi-Fi to work really reliably in a house. But if you've mastered that and you've got that solid, there's no real reason why Wi-Fi can't work really, really well. In his case, he's trying to do Skype over Wi-Fi, and it's just not happening. So it's an unfortunate case in point of how sometimes Wi-Fi can let us down. Well, you can have problems with wired network as well, but from what I've seen, those are easier to diagnose, and the problems tend to be fewer and far between. If you have a problem with a wired connection, most often it could be like a crimp in your Ethernet cable, or a broken Ethernet cable, or a poorly terminated one. You replace it with a different cable, and maybe you've got several cables that are links in that network path. You just replace those links one at a time, and by the time, at some point you'll get everything working again. Wired Ethernet is tends to be a lot easier to troubleshoot than Wi-Fi. Wi-Fi is really tricky. I'm going to take a couple minutes and read through some of the questions while while I'm vamping to see if Mitch joins, and if not, I'll try to tackle the topic as much as I can. Mitch has been, and I'll explain a little bit about who Mitch is. So Mitch is the author of this excellent book. I don't know if you can see this at all, but you can if I cover up my face with it. It's available on Amazon. I've got both the Kindle version and the physical book version. Accurate sound reproduction using DSP. Super great guy. He's been involved in professional audio for more than a decade, and then involved heavily in all sorts of use of DSP and bunches of different software solutions, not just the one that he talks about in this book and the one that I'll discuss a little bit later, but many solutions. He has recently started his own company, and will provide consulting services for audiophiles who are wishing to implement DSP. That sounds a little bit crazy, but that actually makes a lot of sense. Oh, hang on, I've got Mitch calling in. Let me see if I can pull him in. All right, Mitch, I am live, and I'm going to see if I can pull you in if we have video. I don't have audio for you yet, though. All right, I'll let that run in the background, and then if I'm able to hear Mitch at some point, then I'll look at pulling him in as well. Let me switch to this tile anyway, just in case his Skype magically starts working, and then maybe we'll have him here joining us. Anyway, so there's a lot of interesting services that a company like that can provide. It took me, I would say, probably about 3 years or so on and off of kind of messing with DSP and trying to figure out how to make that work well in my room, with help from Mitch's book, with emails and other discussions from Mitch. And in spite of that, I still had kind of a lot of false starts with this whole thing. So if you've got that time and you've got this sort of pioneer hobbyist spirit, definitely it's something to pursue. But you can get a lot of value from getting help from somebody who's kind of already an expert in that space, and the cost is not as much as you would think for getting somebody to help. Let's see here. I hear some noise now, Mitch. If you're on, can you say a word or two so I can see if we can hear you?
Yes. Hello, David.
All right, cool. I think that your audio is coming to the stream. I don't have video for you, but if audio is all we can manage, I'm willing to accept that. I think that's better than not. Oh wait, I've got a little bit of video for you. Cool.
Hello.
All right, I think that everybody will be able to see you now as well. So great. I'm glad we were able to sort of make this work. Your picture is a little bit small. I'm not going to mess with editing it right now, but you're here, so that's great. We've been getting some questions in the stream about audio stuff. What I was doing was giving you a little bit of an introduction and kind of teeing up the subject of how. Let me switch slides real quick. Hang on a second. There we go. I was kind of teeing up the topic of how we, once you have a platform in your house that allows you to deliver streaming audio throughout your home, you've got this sort of, I've been describing Roon's core as kind of like a mainframe that you put in a closet or someplace else in your house. And then you have kind of discrete, very quiet, low noise audio output devices that are doing next to no processing. All they're doing is copying audio frames from the mainframe, if you will, and then routing them to an attached DAC. So once you have that kind of topology, that kind of architecture implemented in your house, it allows you to do some very interesting things with that mainframe. So now you've got this central processing device that is sending audio throughout your house. It's doing format conversions to accommodate the requirements or capabilities of each DAC that is throughout your house. It is potentially doing some upsampling. If some DACs, maybe you've got a DAC that sounds really good at 2496, but most of your music is Redbook CD format. Well, now you can have this mainframe thing upsample to suit the kind of performance characteristics and filters that are in that DAC to optimize that performance without compromising the sound in your audio system by having a machine that's busy trying to do all that upsampling on the fly. Maybe you've got a DAC that likes DSD, and so you need to, if you could kind of play all of your CD collection with the music upsampled to DSD, 128 or 256 or whatever, then you get better sound. If you've ever taken an album like a CD and converted it to DSD 256 as files, you've noticed that it takes an enormous amount of disk space. So it's nice to be able to do that kind of stuff on the fly. Plus, if you're ripping say you've got a music collection of 500 or 1,000 or 5,000 CDs, it takes a long time to rip all those CDs, and it's not something that you're going to do more than once. So if you could make an archival copy of all of your CDs, so as much as possible matching the bits that are on the CD, then maybe now your DAC works best at 2496, but maybe in another room you have a DAC that works better with DSD. You can have this sort of mainframe take that original archival copy of your music and reformat it to achieve the best performance of all the different DACs and devices that you have throughout your house. So there's a lot of power there. What I like to do is maybe have you say a little bit about some of the stuff that you've been doing recently in the DSP world, because this architecture, now that we've got this sort of central computer, this mainframe that's able to do processing, it can also do some room-specific digital signal processing, some room correction, and some other things to make our listening experience deeper, to help us listen deeper into the music. And this can be handled on a per room basis. So you can have different filters applied to each room in our house to get the most enjoyment out of every system that's there, without burdening the local playback devices, without adding noise to each system when we do this. So I'll let you introduce yourself and then maybe say a little bit about what you've been doing in that space.
Sure. Thanks a lot, David. I hope everyone can hear me clearly. Hi, my name is Mitch Barnett, and I'm based out of Vancouver, BC in Canada. I hope everyone is doing well today. And thanks again, David, for inviting me aboard. So, yeah, just to talk a little bit about what I'm doing, just a little bit of background that might help kind of frame what it is I'm about to say. So many years ago, I used to be a recording and mixing engineer for a number of studios in Canada. I spent about 10 years behind the mixing console, recording bands and mixing albums. And I also got involved in room acoustics, building studios, wiring studios and the like. And my formal training at the time, I was an electronics engineer from way back when. So I was fascinated by audio. I love music. Hung out at all the audio stores and listened to music, and eventually got involved in working with a band, doing live sound, which led me into the sort of the studio business. I got to work with some interesting people in the studio world in building a couple of studios from the ground up. Folks may have heard of Live End, Dead End Studios way back when. It was kind of a very new thing that came aboard in the studio business, and really the live end is actually at the back of the room, and the dead end is at the front of the room where all the studio monitors are and the like. And so it's a fascinating world getting involved into acoustics, and I'm not going to go through the whole aspect of acoustical treatments and the like. We can talk a little bit about that, but what I really want to focus in on is the bass response inside of your room. And so there is a fundamental concept where in room acoustics, where the waves and the wavelengths become move from rays, if you will, just like a flashlight ray or a beam that's reflected off of a wall, into waves. And when I think of waves, I think of like if you had a kind of an aquarium half filled with water, and one of those rectangular aquariums, and if you kind of sloshed it back and forth, you're seeing wave acoustics exactly as how it would sound from an acoustic perspective. You're seeing it in water. It's kind of easier to visualize. That transition frequency inside a room is sometimes referred to as the Schroeder frequency, and that frequency is where the waves start, or the sound starts behaving like waves instead of rays. And so there's some easy calculations you can make to figure out the transition frequency or Schroeder frequency in your room. Typically for most small room acoustics, which we all kind of live in, our living rooms, our basements, or even our dedicated sound rooms, there's typically ranges around 100 hertz to up to 300 hertz. And so what happens is, and I know it's kind of, without going through the physics of it, but what happens is that after that transition frequency, and let's say in my room it's 300 hertz, the room becomes in charge of the bass response, not the speakers. And so this is a really tough thing for most audiophiles to understand, and it takes a little bit of time to kind of wrap your head around it. And there's a lot of room mode calculators and positioning, like REW has a great room simulator where you can simulate your listening position in your room and then moving the speakers and the room location back and forth. The listening position back and forth or to the side. You get to kind of see what the room modes do inside your room. Unfortunately, or fortunately, you may have positioned your speakers and your listening position where you're not in a big peak or a big dip in the room. But because of the way that waves behave, they either add or cancel depending upon where you're in the room. If you can kind of remember about the aquarium analogy, in some parts of the room, it will be twice as loud, and some parts of the room, it'll be twice as quiet. And in fact, in most rooms, you'll find that there's a big peak and a big dip based on the dimensions of your listening room, usually situated right in the bass response. And in some cases, and in fact most cases, it can be up to 15 dB or 20 dB of change between one frequency and then the adjacent frequency. So if you're listening to a bass guitar or the bass response inside a small room like that, you'll hear some notes that sound really loud, and then there'll be other notes that sound very quiet, and then some notes that sound like they should sound in balance with the rest of the mix. Unfortunately, for most of us, the reality is that because the room acoustics based on the dimensions of the room, and it really is the dimensions of the room. I should say that there are, appropriate room ratios that some folks use, like recording studios will use to evenly distribute out the room modes. But in most cases, you'll find that in our rooms that you'll be missing a whole bunch of modes down low, and then there'll be a bunch that are kind of piled up together. And what that does is gives your sound system a very uneven bass response. And so that is the primary reason for so-called digital room correction, is to correct the bass response of the room, regardless of what speakers you have in the room. And the speakers only determine the actual low frequency cutoff point in your room. So if you've got some bookshelf speakers, they may only go down to 60 or 80 hertz, for example, but it's still in the modal region and you still can't escape those room modes. And so it used to be that we would use bass traps and other acoustical room treatments to try and smooth out the bass response. I used to work for an acoustics company many years ago, and the bass traps that we use in recording studios are actually built into the room. Because we're dealing with wavelengths anywhere from 56 feet for a 20 hertz wave, or 12 feet or 26 feet. Those are very difficult for a 1 foot or 2 foot or even a 3 foot diameter bass trap to actually try and absorb that wavelength. And so, when I was doing studio acoustics, we would actually build bass traps the size of the rear wall in the back of the room. That's how big it had to be, and the depth was several feet behind the wall in order to properly absorb those long wavelengths. Or other rooms like the live end, dead end that I was talking about earlier, there's actually a room within a room. And so the inner shell of the room would actually pass the bass in below Schroeder and pass it and get reflected in the shell behind in the outer shell. And then there was a bunch of absorption in the outer shell that would make sure it wouldn't re-enter the inner shell back into the room. It's difficult for people to kind of wrap their heads around the size of the wavelengths that we're talking about, and that's why most bass traps are pretty inefficient, anything below 100 hertz. And so unless you stuff the room with bass traps to kind of mitigate that response, the other issue is that bass traps are not surgical in nature. So if there's a huge dip followed by a huge peak, both get attenuated by the same amount, unfortunately. And so it's not very surgical in nature. For sure, speaking of acoustics, bass traps do help. 15 dB variation in the bass response. And the only way to correct it is through the use of digital signal processing without actually constructing another room or breaking out a wall to put in a large diaphragmic absorber or a Helmholtz resonator or what have you for your room modes. Those room mode calculators that you try online, they're actually very good, accurate. I can, calculate the room modes in my room, and I can measure them, and they're exactly where they should be. And even if you're not in a rectangular room and you've got odd angle ceilings or an odd angle room, it only slides, 10 hertz or 20 hertz, but they're still there. And so, by using digital signal processing, this is the way that we can smooth out the bass response in one's room, regardless of the room you're in or regardless of the speakers you're using. So that's just a long-winded answer there, David, of, just so we have digital room correction and the number one reason for it. And then, of course, we can get into, there's, different variations of digital room correction. Some are better response, whereas the really good ones correct both the frequency response and the room reflection as excess phase. And so we could talk a little bit about that if you want me to, or if there's any questions, or
yeah, no, we should definitely get into that. I think one of the questions that I know that folks have is, all right, I'm an audio purist, so isn't DSP just effects processing, like, stadium effect and all this other stuff? Why would I ever want to pollute or corrupt my highly pure audio system by adding kind of this digital processing to the system? Isn't that counter to shortest signal path first and all the kind of audio hygiene things that our audio mentors have taught us, or that we've maybe discovered during our journey into this audio stuff? How do we know that DSP is not just going to ruin all the stuff that we've worked so hard to build?
Yeah, that's a great question, David. And I think that, we have to make sure that folks understand that DSP is not an effect. It's not a, where you can press on your AVR device, for example, large room or stadium. It's nothing like that. It's not adding reverb. It's not adding a spatial effect, anything like that. And so what we're doing is measuring the acoustics of the room from your loudspeakers, and then what we're going to do is process that signal based on some about room acoustics that we know will not have an effect on the overall signal. And I should say that most of these filters, the room correction filters that are designed, are 64-bit filters. And so they're transparent onto themselves. In other words, they're not introducing, the filter itself is not introducing any distortion, whether it be frequency or phase. There's no distortion there. Most of the filters are linear phase filters. And what that means is that they're not actually changing the phase of your system. They're just passing through whatever the phase response of the system is. And so the other aspect, I think, for people to understand is that typically we only apply room correction below 600 hertz. I find that most rooms, if your transition frequency is 200 or 300 hertz, it's usually an octave higher before the room kind of disappears from the equation, and then the speakers are in control of the frequency response and not the room. And so it's definitely not intended as an effect, and it's definitely transparent. And the correction is only as good as A, the measurement, and B, the actual algorithms that are being used to produce the correction. And there's a whole pile of science behind that as far as what is being corrected, what is not being corrected. There's a lot of folks that, if you've listened to Floyd Toole and Sean Olive and those folks, mid-range and high-frequency reflections are a good thing. They add more to the mix of the music, and so rather than sounding like a padded cell where you've got a lot of acoustic treatment in your room, really room correction's only trying to correct for the lower frequencies, and it does it a way as not to affect the actual music, because all we're doing is looking at correcting the room. And so maybe I should explain that a little bit more so that people really kind of get what I'm saying. Basically, if you look at a speaker, it would be deemed or called what's called a minimum phase or a minimum phase system. And without getting into the math about what a minimum phase device is, essentially what we're trying to do is make sure that loudspeaker, the sound coming from the loudspeaker, is arriving at our ears in our room without too much interference from the room. So, of course, the direct sound that's arriving at your ears is, if you look at the psychoacoustics behind it, basically that's what determines the frequency response, or what we perceive as the frequency response that we're listening to. Unfortunately, room reflections get in the way, and especially at the lower room reflections where they're bouncing back and forth from the walls, and at your listening position, they're either adding or canceling or somewhere in between. And so what we're hearing is the direct sound and then some reflections directly after that, which then alters the perceived sound that's reaching to our ears. And so those reflections are called excess phase from a low frequency perspective. And so what that means is that if I took a measurement of the loudspeaker in the room, there's two components to it. There's the minimum phase component, which comprises of its frequency response and its timing response or phase response. And then there's the excess phase, and that is everything else that's not the direct sound from the speakers. So all the room reflections, for example, that come into the microphone or into our ears after the direct sound has arrived. For the most part, mid-range and high-frequency reflections are kind of a good thing. That's what gives the diffusive sound nature. But at low frequencies, this is where the problem comes, where we've got these cancellations, these big dips, these big peaks in the room. And so there's various mechanisms that have come out over time Some of you may remember 10-band graphic equalizers. I've used my fair share of those way back in the day. 31-band equalizers, 1/3 octave equalizers, parametric EQs. All of those were electronic devices when I was kind of in the business. And then as software and computing power became cheaper and better, all of those devices were now mimicked in software. And so, I still do recordings from time to time, but all of the effects racks, if you will, that I use, they're in the computer now, and all digital signal processing, they're not outboard racks. And so this is what's happened with equalization as well. It's now all kind of software-based. But then there's still the equivalent of the 10-band equalizer in the software. And so this is where we get into which room correction software is good. And so there's various curves, if you will, on the ratings of each room correction software. And so when I talk about room correction software, I'm talking about software that's dedicated for digital room correction. There's lots of do-it-yourself techniques using REW and sometimes rephase, and those can produce some pretty good results, but they're definitely not room correction software that's been specifically designed to take out or minimize the interaction of the low frequency response in the room. And you can really hear a difference when you use kind of that digital room correction software and compare it to other mechanisms or other methods of doing it. And so the advantage of the room correction software in the FIR filter that's produced, or FIR, or finite impulse response filter that's reproduced, is that when you correct the direct sound of a minimum phase device, like the loudspeaker, you're not only correcting the amplitude response, but you're also correcting the phase response. One follows the other from a minimum phase device. However, when it comes to room acoustics, we're talking about excess phase or mixed phase or something other than minimum phase. And so that can't be corrected using a minimum phase response. You now have to use some other mechanism, and that's where the real digital room correction software corrects these time domain disturbances in your room, because that's what they are. It's not the direct sound that's given you the wacky frequency response. It's the fact that it's reflected off the front and rear wall and either added completely together at your listening position or completely canceled itself out. And so that is where the difference is between, so-so or just frequency response correction, like what REW use, or techniques like the moving measurement microphone technique, or MMM technique. That's another technique that is used to kind of smooth the response, but it's only in the frequency domain. It doesn't take care of the room reflections. And so, the other part of the problem is, you might say, well, the bass sounds pretty good in my room, except you kind of got used to bass response that may not be sounding as even as it should. And that's because every room we're in has that characteristic. And so our ears get very used to that quickly. And unless you've actually heard a properly digital room corrected system, or been in a recording studio or in a larger venue where they don't have to worry about these kinds of room effects, all of a sudden you start hearing, wow, I can hear every note of the bass sounds clear to me. There's no variation in level. It sounds nice and tight, clear. That is what we're all after in our listening rooms. And so this is why we use digital room correction. It's about the only mechanism available to correct or smooth the low frequency response. Again, if you have acoustic treatments, those help. They do assist. And again, stuff like bass traps in the corners are very useful. But when it comes to fine tuning or getting rid of those huge peaks and dips, digital room correction is the way to go. The other thing I should mention is that our ears are much more sensitive to peaks than they are to dips. And so we have when there's a narrow dip in the response, we don't worry too much about correcting that. That's basically a null point or a point of complete subtraction. And so, just by raising the amplitude of that isn't going to help because you're in a null. It'll just keep canceling itself out. And what usually happens, and this is where we get into why some of these other systems aren't very good, is because they'll want to boost frequencies. And the moment you start boosting frequencies, you have effects on adjacent frequencies. And so really good digital room correction software only cuts, never boosts the frequencies. And so we're only looking at taking down the peaks as much as we can to smooth out the response and just leave the narrow dips alone. Our ears and brain just fills in the response, and it
cool.
still sounds nice and even.
I think you make a good point, especially for modern loudspeakers. If you take a look at modern loudspeakers, stuff that's made like in the last 10 years, they tend to do a lot more kind of measurement-oriented design, at least above a certain price point. I mean, I think even like the little $200 or $300, $400 PSB speakers, very kind of measurement-driven. The on-axis or direct response from those speakers is surprisingly flat. And for a lot of loudspeakers, I think that you're going to get, unlike kind of the 70s and 80s, where you had the California sound or the Boston sound, or speakers that were kind of all over the place as far as response goes, because it's kind of whatever flavor you liked. Modern loudspeakers tend to be, just in their kind of direct response, it tends to be pretty good, and it's really kind of the room and the integration of the room, maybe the diffusion of the loudspeaker and how those reflections interact with the room that kind of spoils things. I think it's also useful to point out that if you've got, and I think most people here are aware, but if you've got like a big coffee table, a big glass coffee table sitting in that kind of triangle between your ears and the speakers, DSP is not going to solve those harsh reflections. I've seen cases where it can make it worse even. Since the measurement microphone may be kind of confused about what it's picking up when it hears that direct sound, and then the sound from the tweeters bouncing off of the coffee table a few milliseconds later, and trying to make any kind of sense of all that stuff. So, I mean, common sense still applies. I think I've described applying DSP to a very, very live, glass-filled room and with no carpet and all that stuff is like putting lipstick on a pig or lipstick on a mule. It's just, it's not going to make it better, right? And it might make it, it's still going to be a pig or a mule. So it makes sense to, like you say, to apply kind of common sense treatments to your room. Make sure that that it's not too live. If you've got the ability to add some treatment at the first reflection points, there's all kinds of different advice. Some advice says absorption is good, some says diffusion is good, but if you've got something that's harsh that will it's at that first reflection point, like, it still helps you to do something about it. DSP doesn't eliminate the need to consider those things, I think, is the point that you were making. So cool. Let me see what other questions we have, since I know that there are a number that have come in. We touched on this already a little bit. The question is, if I can make some changes to my room and setup, what should I consider doing before implementing DSP corrections? You talked about like corner bass traps are not a bad thing if you can do those. A carpet on the floor, all the kind of normal stuff that you would do with an audio system if you're trying to make your room sound good. All that stuff applies in a situation where you're contemplating enhancing things with DSP. DSP will just make a great system sound even better. It can make a good system sound better too. If the room is a terrible room, maybe it can help a little bit or not. You want to touch on like DSP in terrible rooms?
Yeah, sure, David. Yeah, so DSP does work very well even in terrible rooms. For example, I've got the second worst room you can have, and so that means that my ceiling is 8 feet. the width of the room is 16 feet and the length is 32 feet. And so they're all multiples of 8. And so the only worse room than that is a perfect cube. And so nonetheless, I'm able to completely flatten the response of my system. I've got a couple of large subwoofers in my system, along with some big bass cabinets. And I can get a flat response almost down to 6 hertz in my room. I guess there are double 18 subs and double 15 woofers on each side, so it's a lot of cone area. And a lot of power. I get about 3 kilowatts of power going into that system. So I like live concerts and rock concerts, so I can sort of simulate the pounding of the bass in my room pretty easily. But at the same point in time, it sounds extremely even and transient. And I think, when you're looking at placing stuff in your room, as you've already kind of described, I've got my stuff set up in an equilateral triangle, and the reason for that is that having worked in the studio for 10 years, everything was in an equilateral triangle. That's kind of the spec. People keep saying there's no specifications for recording, mixing, and mastering, but there actually is. So there's European Broadcast Union standards, international ITU standards on monitoring in critical listening rooms, size of the room, reverb time of the room, decay time of the room, the angles that everything is supposed to be set up within the triangle. It needs to be within 6 to 9 feet is the specification. And there's a bunch of other specs that go with it, including the type of monitoring speakers, not too narrow directivity, not too wide directivity. There's a whole bunch of specs that go around that, including the operational frequency response. And so when I was working in the studio, most of the large format monitors were equalized to one of those standards. And so it's very common to see that. But in my room, I use one of the standards as well. And, so some people will want to not only EQ or take care of the low frequency room resonances. That's job 1 of DSP. Job 2 of DSP is to, if your speakers are a little too bit bright or can make some gentle tone control corrections, but they're not like a typical shelving tone control. They're actually a tilting tone control. And the reason why I bring this up, and you've mentioned this point earlier, David, is that most modern loudspeakers have excellent on and off axis response. Floyd Toole and Sean Olive has spent both their lifetimes not only measuring loudspeakers. You'll hear things like spinorama, where a loudspeaker is placed in an anechoic chamber, and either the speaker or the microphone spins in 72 different locations around the speaker to get a perfect viewpoint of what the speaker is able to produce. Those are now embodied in a standard, an ISO CTA 2034A standard for measurement of consumer speakers. And that standard's been out since 2015, and most of the loudspeakers manufacturers are starting to pick up on it. It's the latest standard for loudspeaker manufacturers to properly design their speakers, because as Floyd Toole and Sean Olive have figured out, that the speaker's off-axis response is just as important as its on-axis response to give uncolored neutral sound quality. And so forums like Audio Science Review, run by Amir, he bought a Klippel near-field scanner, and he's been measuring speakers for folks that want to check out the site and look at some of those speaker reviews using that CTA 2034A standard. And so that's a great place to start, is to first buy a decent set of speakers that that really well based on the science. And then the second place to start is just to get a basic handle on your room acoustics. What's interesting is that the specification calls for broadband reverberation time of small room acoustics about between 300 and 600 milliseconds. And so you'll find that in most average living rooms, if you've got a couch and furniture, some carpeting, some drapes, and just knickknacks all over the place, you'll find that your reverb time in your room is probably pretty close to the standard. And so it's only rooms that are completely empty that someone has decided that they want to build a sound room. Then they might be looking at some acoustic panels or, aside from the bass traps, something to bring down the overall reverb time of the room so it just doesn't sound too lively. The problem with a too lively of a room is that it's makes the stereo image very diffuse sounding, and so it's hard to pick out the location of the performances and the like. Conversely, too dead of a room kind of sucks or drains the life out of the music, and so there's a good balance between not too dead of a room and not too lively a room, and ironically, as it turns out, most of our living rooms kind of as is fit into that category of a decent room. So treating the first reflection points is a good thing if you'd like, but for the room acoustic software, digital room acoustic software, the real good ones typically go for, $300 or $450. That's not a lot of money. That might buy you 2 bass traps, maybe 1. And so for that amount of money and a measurement microphone, the UMIC one is fine for $100. Make sure you get a calibrated one. So, for $450, $550, you've basically got the software and the microphone and everything that you need in order to take some measurements and try and understand how to use the software. And of course, there's tons of material out there that myself and others have written on how to use these softwares, step-by-step ways to use the software. And I think that, for the money, that's about the best bang you can get. Anything that you can take a room where there's, 20 dB of variation in bass response and bring it down to plus or minus 3 dB, which is what the studio control room response is for the people that mixed the sound and mastered the sound, then all of a sudden you've got super even bass response in your room for not a lot of money. And the correction filters, I should say, they can be placed into Roon, for example, has what's called a convolution engine, and so does JRiver and Ottervana, and a bunch of others have a convolution engine. And just taking a second to explain that, basically what that means is that as the music is playing, it is being convolved in real time with the filter that is being used for your room. So basically at the low frequencies, there's 2 things going on. One, we're inverting the response, no boosting, but we're inverting the response. The correction filter is inverting the response that it sees in the room. And also separately, which is why it's a FIR filter, because you can, in a FIR filter, it can contain both the frequency and phase correction for the speaker, but also the room correction, the timing response, separately can be applied in the filter. And so that means that I'm applying all aspects of the room correction in a single filter that can be hosted
and the neat
as
thing
a
about
file in
Roon
a
compared to other
convolution
solutions
engine.
that I've messed around with is that if you have multiple systems in your room, we've got several in our house, you can have a separate set of filters for each environment. And in fact, you can have multiple filters for the same environment that you can even stack together. So for example, maybe you've got a correction filter for your room speaker, loudspeaker and room combination, and then you might build another filter or layer another filter on top of that that does equalization for some records that were produced in the 70s that were mixed a little bit too thin, maybe because they were mixed at too high a level, or maybe you've got a down the road when we can process vinyl sources from, or maybe you've got some needle drops that were recorded without RIAA equalization. You can digitally apply that RIAA equalization without getting some of the phase errors that tend to be common in all but the very best phono stages. A couple of questions from the stream that I'll introduce here. So Phil is asking, how large a room would you need for correction to be completely unnecessary? You mentioned earlier that like larger performance halls tend to give a more even response. So how big of a room are we talking about where room correction doesn't apply? And along those same lines, does near field listening alleviate the need for bothering with room correction? I think in my head anyway, those two things are kind of related.
Yeah, so in most auditoriums or theaters that are designed for sound reproduction, very rarely is room correction, low frequency correction required. The wavelengths the room dimensions are so large that the wavelengths go through a number of cycles before they actually get to a reflection point in the room. And by the sheer matter of the length involved, by the time it comes back to your ears, it's considered a late reflection and not an early reflection that is messing up the tonal response of the sound reproduction. So, sometimes what's used is loudspeaker correction for those large halls where they're just measuring, making sure that they've got a nice flat response coming off the loudspeaker stack and not worrying about the room. Because the room is going to have very little impact to the sound as far as equalization is concerned. So measuring flat at the three meters from the loudspeaker stack, which is typically what they do in sound reinforcement for concerts, that will have the same response as it will when you're 100 feet back at the mixing console. I've done it myself many times, and that's what we typically do. We don't worry about the room. Now, near field monitoring is another interesting scenario, and I can't show it right now, but I'm sitting at a desk with a couple of monitors on my desk, and so it's not so much the low frequency correction that we're looking for in near field monitoring. What we're looking for is to smooth the mid-range or the high frequency response, especially if you're getting any bounce off of your desk. It's good to angle the speakers, if they're sitting on the desk, angle them up, pointing them towards your ears, that kind of thing. And so what happens is that now you're dependent upon the frequency response of the loudspeaker in a near field monitoring environment. And even the ones that are really flat still are not quite as flat as one would like, even when you're literally like a meter away from the speakers. And so if you look online at Soundstage Network, for example, they've got some great anechoic measures of a ton of loudspeakers. I've got a pair of KEF LS50s, for example. I use them in a near field monitoring situation. They're just a little bright, hertz range, and so rather than fiddling with parametric EQ or graphic EQ, I still use room correction software to smooth the response. And you have complete control over the frequency response of the loudspeaker, not in a negative way, but simply that you might find it an uneven response still, and this will smooth it right out to the point of headphone level is basically what you can get down to. Super smooth response with room EQ applied in a near field.
Cool. Yeah, no, position. I agree. Yeah, so it sounds like there's some benefits to applying this in pretty much all cases. And for domestic, some people, especially back east in Atlanta area, have some pretty big houses compared to sorts of spaces that we tend to occupy out here in California, unless you're in Menlo Park and your last name is Zuckerberg or whatever. But it's unlikely. It sounds like, given the wavelengths we're talking about, what is a wavelength that the lowest note on a grand piano is 27 hertz. So what's the wavelength of a 27 hertz? Is some 50 feet or something like that. So in order for that wave to complete several cycles, you're talking of 100 or 150 hertz is the larger dimension of your room. There are not a lot of people in Atlanta that have that kind of real estate for their two-channel listening system. I'm not going to say there are none, but it would be an unlikely scenario that they would have a room that's large enough that level of correction wouldn't be beneficial to them, it sounds like. Let's see, another question I saw. Phil Connolly was asking, is there a DSP system that can help out with analog sources instead of just digital? The context here in this talk is really kind of around streaming, but are you aware of any? Have you kind of worked with convolution and those kinds of solutions for vinyl or tape playback or SACD or something else?
Yes, so I do have a turntable system that I use, and I have an analog to digital converter. And so what I do is just simply take the output of the turntable. It goes into a preamp, just a phono cartridge preamp, and then the output of the preamp goes in. It's now at line level. The line level goes into my analog to digital converter. It gets converted to a digital signal, and then I route it through the digital input of JRiver, for example, the ACO line input or the Wasapi line input. You have a couple of choices there. There's also a Windows Device Manager, a WDM input if you want. And then it runs right through, passes straight through into the convolution engine and out to the amps and speakers. And so it's literally in real time. There's probably about a second or so delay between when you listen to drop the needle on the record and by the time it comes out out the speakers. And I've done RIAA correction also in the DSP. Some of them are really quite good. For example, AudioLens has and Accurate has both have facilities for RIAA, D-Vinyl. D-Wave, I should say, have several different profiles depending on what era of records you're listening to. And so I find that to be quite an excellent solution. It's always a surprise to me and to my family when I bring out the record player and play some records, especially for my 16-year-old daughter. With the first time she saw it, the very first thing she asked me is like, "What is this?" She had never seen a record before, never seen a turntable before, right? And so, and then when I kind of dropped the needle on it and music came out, she was kind of just blown away, and she's kind of looking at it going like, how does this even work? And as I explained it to her, her first thought was, wow, that's really dumb having some sort of needle scraping along a piece of plastic. So it's kind of interesting to see in different viewpoints. But for me, I've been a long-time vinyl collector for a long time. In fact, I used to live in a small town as a teenager, and we used to wait weeks for the local record store to get in a new shipment of records. And so I've got a lot of collector's items and various EPs and special pressings and all that nonsense from years and years ago. And it's a great thrill to be able to bring them out and play them. So, it still has to be converted to the digital domain. I've written a number of articles on audiophile style, or used to be computer audiophile, on how to do that, both for the Windows platform and the Macintosh platform. And so there are a variety of ways to do it, but that's the most common way of doing it. And it still sounds like vinyl. Like, this is the thing, like the analog to digital conversion is completely transparent. The digital processing itself is completely transparent. And so when I listen to it, I can't tell any real difference if I just simply drop the needle on and play it through my system versus dropping the needle and then just having it going through a regular integrated amp into speakers. The difference is that I can't get the great sound because I don't have room correction in the circuit. And so I'm just getting whatever is coming off. But you can still hear the vinyl sound. It definitely sounds different to my ears.
Sure. And I know I've
just,
talked to
regular
Bob Katz,
digital, if you will.
and he's written at length at how he uses some software called Accurate Convolver. It's another, I don't know, $150 or something like that. It's a strictly ASIO type of thing, as far as I recall. I've got a license for it. I haven't used it a ton, but sometimes I use it for checking measurements, and it does a good job of sort of presenting a virtual sound card type of interface, and it will it'll digitize your analog signal, and then it will present an ASIO interface that has the convolution applied that then other playback software can kind of pick up. In Roon, unfortunately, right now we do not have an input zone, is what I would like to call it. We've got output zones, but there is no input zone in Roon. I've been looking in the community, and I know that people are talking about how they've been working around that and had some success at doing that. I know that it's something that the folks at Roon Labs are looking into. I'd be very surprised if by this time this next year there isn't a kind of Roon supported solution for routing your vinyl records through Roon and then being able to play them throughout your house. The folks over at Sonos have been doing this for nearly a decade, or maybe even more than a decade. So it's not like this is a new thing. I think it's just the Roon guys kind of prioritizing features and capabilities, really wanting to get this digital streaming part right before they start taking on the complexities of working out analog. They like to have a very attractive and beautiful metadata presentation with artist bios and song lyrics and all that stuff. And how do you do that when you're just receiving a digitized analog stream? What does that experience look like? They're going to figure out all of that stuff. I don't know if they'll do some sort of Shazam-like AI recognition of what audio you're sending it and then try to give you some album art to go along with what you're playing, or if they'll just give you some sort of picture or something. But it'll be interesting to see. But those kinds of things are coming. Let's see. I'm going to look at what other questions we have here. Let's see. Oh, how does the one question I thought was pretty interesting? Somebody asked, how does playback level affect my perception of tonal balance in my system in Roon? You and I had a conversation about this earlier, but maybe touch on some of the stuff that we talked about there.
Yeah, sure, David. So, and that's a great question, and one of the things that I think that a lot of audiophiles don't quite fully appreciate. So, when and let me talk to it a little bit on the production side, and then we'll talk about it on the reproduction side. So, when I'm in the studio and I'm mixing down a song or mastering a tune, and I'm getting to the point where I want to have a final mix or a final balance, there is a prescribed sound pressure level that you should be listening to, and that's roughly between 77 and 83 dB.
C weighting? Okay, I was going to ask you what kind of weighting applies.
C weighting on, so C weighting on your sound level meter and slow integration as well, and so, or average response, if you will. And so there's a couple of ways to calibrate that. One is to run pink noise through your system and set your volume control so that it is that level. Or just listening to compressed music will also give you kind of the average level. But it's really important to think about this because what happens is our ears have a nonlinear response, especially at the low frequencies and the upper end. And so what happens is that at lower SPLs than 83 dB SPL, for example, our ears' response is not linear. So as the level drops, the bass response of our ears actually drops off quicker than the rest of the frequency range. Conversely, if you go past 83 decibels up to 90 or even 100 dB, which is really loud, you'll find that our ear's response to bass frequencies is actually greater than the rest of the level at that range. And so that is something that is really important to understand, because our ears have the flattest response at roughly about 83 dB SPL. And so what happens is, and one of the reasons why there's different mixes don't sound as good compared to other mixes, is because, think of it this way, used to be an ironic story in the 70s where some of these rock bands would listen in the studio at like 100 dB, and so they would be mixing the sound at 100 dB. Sounds awesome. Sounds like it was when they're at the concert. It's really loud, sounds great. The problem is that when they go back to play it in their home system, for example, and they just turn it up to 80 dB, and they go, wow, what happened to the bass response? It sounds so thin. It sounds weak. I mean, it sounded fantastic in the studio, and everyone's scratching their head trying to figure out, well, what went wrong? What went wrong is that they mixed and mastered at such a high level that at that level, the bass sounded just fine. But as they dropped it in level, and our ears' response, bass response, drops even further in level as it's being down, all of a sudden the mix sounds really weak, sounds thin, there's no bass to it. And so there's a lot of albums in the 70s that were mixed on JBL monitors where there was pounding bass at a high level, but when they brought it down at lower levels, it's disappeared. So the trick that folks do nowadays when they're mastering or mixing at 83 dB SPL. So I had a sound pressure level meter all the time at the studio, always checking my levels, and pretty soon you kind of got used to it, and you very rarely had to use the meter because you knew what it sounded like. But I also have it at home. And so I calibrate my home system to 83 dB SPL with the pink noise, and when I critical listen, that's the level I listen at, because that's how I know it was mastered at the studio, or mixed and mastered at the studio in the mastering facility. And so that gives me the same bass response what those folks were hearing on their monitors when they mixed and mastered it. And so this is one of the reasons why folks use loudness controls as well. And you set it up so that the loudness control doesn't engage at 83 dB SPL, but as it drops in level, the loudness control kicks in, so that when you're listening at a really low level, like nighttime or what have you, your system still sounds nice and full, because it's the loudness controls compensating for the drop on bass response your ears have when the overall level has been brought down. And that's another enhancement that I hope Roon makes, is that folks should really be using a loudness control if they're not listening at critical listening levels, so that they can at least have the full bass response experience when they're listening to playback music. So a lot of people don't understand that the bass response changes versus sound pressure level as far as our ears are concerned. And so I also calibrate sound systems at that level as well. So 83 dB SPL or 77 to 83, depending on how much compression is being used for the music. That kind of, make sure that your system's tuned at the
as far as I
right
know, Roon
frequency
doesn't
response at the
currently
right
have
level.
a loudness feature that might be interesting for them to add. But they do have a, which I think is kind of related and also helpful, a volume leveling feature. I personally think that this should be enabled by default in Roon. I've been asking them to do this, and I'm hoping at some point they will, because it does help to partially solve that problem. So what volume leveling does is Roon takes a look at what we call R128 metadata that is embedded in the stream of music that comes from Tidal. I think Qobuz now has been adding this metadata to their streams as well. It's important for streaming that this be added to the metadata, because when you're streaming, a streamer doesn't, streaming from the internet doesn't have the opportunity to kind of listen to the entire album to find out what the loudest and softest parts are and what the average levels are. It's not possible because we're just looking at little bits of that album or that song that are coming in real time. So that analysis has to happen kind of offline before the first second of that album is streamed to us, so that we know what kind of math to apply to get the volume leveling set to the right spot. So looking at that R128 metadata, Roon is able to kind of decrease the playback level, so to achieve kind of an overall target, what we call a LUFS target. I can't remember what LUFS stands for, but that's a thank you. Yes, it's that target.
Loudness units.
We need to have that metadata in order to achieve that target. So when you point Roon at your local library of FLAC files, you'll find that it relatively quickly discovers all the albums in your collection. But depending on how large your collection is, it could take several days or even a week for it to listen to every single song in your entire library and try to work out what the volume level is for each of those albums, so that it can apply that correct calculation to volume leveling when you're listening to them. I found that if you try to play an album before that analysis is finished, like the first 5 or 10 seconds will be relatively loud, and then it'll say it'll have enough time to have listened to all the rest of the albums on that track, and all of a sudden the volume level of that album will drop. I've had this enabled for quite some time in Roon, and I find that I'm able to set my preamp to kind of the same setting that achieves right around that kind of 83 dB median output for all the music, and I almost never have to touch my remote control to adjust the volume again. I'm able to just sit down and listen, and it is so nice. I mean, we listen to music for pleasure, for enjoyment, and so things that can make that experience more comfortable, more convenient, easier. There is such a thing as audiophile masochism, and some people get some pleasure out of things being difficult as well. But for me, diving for the remote control whenever I want to switch from one album to another or one genre to another is not one of those things that gives me pleasure, and I do not miss having to do that anymore. It's such a nice feature to have. I think what you're saying, that combined with some DSP that automatically accommodated or calculated kind of the average human ear's response variation in loudness to low bass, would probably make that an even nicer solution. Let me look in the stream for another question, and then Mitch, I'd like you to pause and tell us a little bit about the company that you started and some of the services that you've started providing to audiophiles to really kind of help them use this technology to get their rooms to the next level. Hang on a second here. I had a question that I was just looking at. Phil asks, do you need subwoofers to correct the bass response, or can it be done without them? I imagine this is an it depends question, but I'd love to get your thoughts.
Yes, no problem. And before I answer that question, I just want to make one more point that you were making about the volume leveling. So once you've tuned your system with DSP, for example, you will notice a huge variance between different levels, volume levels of each tune. That becomes even more apparent when you've DSP'd your system, number one. And number two, I think it's really important for people to know that this is just metadata. It's not actually doing anything to the actual audio signal itself. It's just simply lowering or raising the overall level. So as each tune is played, they're at the same level. And so I've been using volume leveling since it first came out. There was an initial pass before the RE128, and that didn't work so well. But this latest version seems to have nailed it right on, and I really appreciate that, because this otherwise for every single tune I was reaching for the volume controller, had to adjust the volume. Then you got to get the meter out, and then it's like, wow, man, this is like a you know what, right? So, okay, so to answer the question about subwoofers, so, this is an interesting topic. You'll find all sorts of information. Todd Welty, for example, from Harman, on multiple subwoofers. I've forgotten Du Coluchon from, I forgot about the Swarm Woofers. Also, Earl Geddes has a number of multiple subwoofers and schemes around that. It depends on what you want. And so to quickly answer the question, no, you don't need subwoofers to get a nice, smooth, even bass response out of a pair of stereo speakers with DSP. You can do that no problem. Subwoofers assist in that smoothing of the response by simply adding them to the room. And there's a number of schemes. If you look at Todd Welty's paper on how many subwoofers do you need and where to place them will give you the best response. You still need DSP in the end. And no matter what you do, the variance is still there. It may be reduced with subwoofer, and in fact, in some cases, it may be really enhanced because all of a sudden, your satellite speakers weren't activating that lowest room mode, and now you've put in subs in the exact spot where you've got a whole pile of maximum phase, and all of a sudden, it sounds like how you blow on the top of a Coke bottle to get that resonance. That'll sound like that at low frequencies. And so, there's, even though I've got full range speakers that go down to, I think they go down to like 32 hertz, I still use subwoofers. And even though I mostly listen to rock and pop, some classical and some electronic, and everyone kind of has their view on how much bass there is in modern recordings. I think people underestimate how much real low bass there is. There's actually quite a bit in all sorts of material that you listen to. And especially if you want to have that weight or that kind of really deep feeling, the only way to achieve that is through a subwoofer. Now the problem becomes, how do I integrate those subs into my system, not only from a positioning perspective, but electrically, how do I do it? How do I do the crossover? Where do I cross over? The irony is that the standard manufacturer says, hey, you should cross your subs at 80 hertz. That's the mantra you hear everywhere. Unfortunately, if you run the room mode calculator, you'll actually find most rooms have quite a bit of sensitivity around 80 hertz from a room mode perspective. And so that's actually the worst place you could put your crossover, because now you've got a point of maximum energy, and now you've got both the satellite woofer and the subwoofer crossing over at the most maximum energy point, and now you've got two cones adding to that energy point, and that produces a huge resonance peak. So as a pro tip, if you just run the room mode calculator, you'll find the room modes in your room, and then find a spot in between room modes to cross your subs over. And so that way you're not activating where the two speakers are producing the same amount of energy. You're not activating that in a room mode. So that's just one tip to say. I think the other thing is that personally, I would always use subs for music reproduction, just because there is a lot of content down there. And if you do a lot of looking at frequency spectrums or FFTs of music, even though it may be 20 dB down at 20 hertz, there's still some content being put there. And if you put in a filter to cut off everything below 20 hertz and flip it off and on in semi-blind test, it's relatively easy to feel one feels just a little bit less weight than the other. So I have two subwoofers in my system. I have you can use 1, 2, or 3, and as Todd Welty and most of these other reports have shown, Any more than 4 is overkill and not going to help smooth out the room modes to a certain degree. Also, there's a whole bunch of schemes that people use as far as high pass, low pass filtering at the crossover point, whether the satellites should be run full range and then just a low pass filter applied to the subs, or what have you. Personally, I like to use a real digital crossover in between the subs and the mains, so that there is definite separation of tasks, number one. And number two, I like to time align the subwoofers with the mains so that the main impulse response, the main step response, or the direct sound of both the subs and the mains are arriving at my ears at the same time. That gives the biggest and most impactful transient response that you can get. Typically, you'll find even if you have the subwoofer in the same plane right beside your speaker, that there'll be roughly between a 2 to 3 millisecond delay between the main speaker and then the subwoofer firing. And the problem is that if some people kind of like that sound, it kind of sounds late. The bass sounds late, and it gives a fuller sound, but it's not transient. And so, if you listen to a classical music where there's being a timpani or a bass drum being hit, it sounds weird because you feel the initial impact. And then there's a second wave behind it, and then it kind of goes back and forth, and my head goes to the side because it's like, well, that sounds odd. That doesn't sound like a bass drum where it just goes boom, and it kind of goes boom. You kind of get the effect right after it, and so I have a specific viewpoint on that. However, if you're an audiophile and wanting full range music, I think it's a tall order having even large mains, and I've got pretty large mains that go down pretty low, but the subs go lower. And so, subwoofers should sub. And so that octave, typically also, I look at the natural roll off of the mains. In my case, it's about 40 hertz that my speakers start rolling and the mains roll off. So I find a crossover point. Right now I've got them at 46 hertz. And the reason why I have that is that at 40 hertz, I have a room mode, and at 60 hertz, I have a room mode. And so I kind of slide in between the two room modes. And that way I've got really nice coupling. I'm using the mains to their full extent, but alleviating the absolute bottom octave there, so that it's put to a purpose-built speaker that's designed to cover that range. Whereas the intermodulation distortion, or just even the THD, goes way up the lower that you go in frequency. Even if you have big mains, you'll still see it rise. By the time you get 40 hertz, 50 to 40 hertz, you'll see it start going up quite a bit. And by the time you get to 20 hertz, it's in double digits of distortion. And so having a sub really alleviates all sorts of issues, but it brings itself some own issues, like all of a sudden you've got to worry a little bit more about placement, depending on room mode activation, and then the integration between the mains and the subs also takes helpful. A little bit of effort.
I'm using smaller subs, and I have a much smaller room, much smaller speakers. So my speakers are 7-inch two-way speakers, and then I have 8-inch subs from Rel. My speakers roll off. Yeah, thanks. My speakers roll off. Nice. Or from Fritz, they roll off pretty rapidly below 36 hertz, since they're a ported design. And so I'm able to use the natural roll off of the speakers, and haven't bothered with a high pass filter on them. And have been able to get really good integration with the subs, just having their own analog low pass filter in them. And so you've got a bunch of different options. I'd love to try the kind of active crossover between them at some point, but in my little space, It's not something that I've got effort to put into, but I have to my ears anyway, very satisfying sound. Without that, I don't want everybody to feel discouraged or to think that they can't achieve sound that they like unless they go to, all of the extremes. There's pros and cons and compromises all the way along the way, but you can get very good results.
Yeah, for sure.
Yeah, for sure,
Absolutely.
for sure.
Whatever
all right, so
works, right?
you have you've written this book, which I showed everybody the cover of before you came on. Thank you for that. Super helpful. One of my favorites. I'm not holding it the right way. I need to get you to come out here and sign
awesome.
it, or fly up to Vancouver and have you sign it sometime, so it'll be real. But super helpful book. I know that you've learned and you've done a ton of things since that book. Maybe catch us up on what you've been up to since you published this thing, and tell us a little bit about this company and service that you've started, and what, if folks were looking at maybe considering going that route, what that entails. What are they looking at in terms of time and cost, and what the results would be versus going it alone?
Yeah, sure. Thanks, David. And so just to be clear, that book is probably now 4 years old, or almost 4 years old, and so all of the procedures and all of the concepts still apply. And in fact, most room correction software, regardless of brand, will work that way. And so that's a great place to start. I've written a ton of articles on digital room correction, covering a number of products that can be found on my website. I guess I've been kind of doing it for 10 years now, I guess, and tested virtually every digital room correction software there is out there. And some formal reviews, and kind of been a hobby of mine for an awful long time. And so recently, over the last, I guess, 6 months, I've been spending more time on that, and opened up a business called accuratesound.ca. And that is my website location. And basically, it's offering professional services around digital room correction, loudspeaker placement, acoustics, consulting, selection of products, subwoofer integration, those kinds of things. And typically what most people are after is just the digital room correction and getting that to work. And so typically how it works, I get people to take left and right sweeps of their speakers, or measurements of their speakers at the listening position in REW, for example. They send me the file, I have a look at it, and run it through a bunch of different views and compare those to industry standards, and send back a report saying that the reverb time of the room, or the looking at the waterfalls or the low frequency to decay time, energy time curves, step responses to the loudspeaker, frequency responses, phase response, group delay, all of that good stuff. And produce a little bit of report to just show the difference between, the standard and where you're at in your room. And that I do that for free. That's just kind of fun for me. I get pictures I get people to send me pictures of the room and the measurements of the room. And I've gotten those from all over the world over the last 6 months. It's been kind of fascinating seeing all sorts of different speakers and rooms. In fact, it's just kind of mind-blowing, some of the systems I've seen and some of the rooms that they're in. It's fascinating to see what people have done. And then usually, whether you're using Accurate or AudioLens or REW or DAC or DRC, which is an open source digital room correction software, what I can do is produce up to 6 different filters, and we kind of go back and forth on designing a filter, implementing that filter, sending that filter to you. You give it a listen. Is it too bright? Is it too dead? Is it whatever? And then through an iterative response, we go through and narrow it down to your own personal preference as far as what you like to hear from your sound system. But the guarantee is that it's within a plus or minus 3 dB tolerance, frequency response tolerance, and that's kind of what the studio response or control room response in the studio would be. And so basically you're hearing what the artists intended or the engineers or producers intended from the recording. And I've taken a lot of my material that I've recorded over the years and played them back on my speakers here, and it sounds almost identical. The difference being is that I, didn't have a several $100,000 specially built acoustics room to be able to listen them back in. And in fact, that's one part of the story. When I was doing the recording and mixing for a living for 10 years, after I kind of got out of that and into the software world is where I went to next because of the downturn in the market at the time. I honestly gave up on my stereo system. I just listened to headphones for probably about going on 15 years because I couldn't handle the room acoustics of the places that I was in. And after being in the studio, I mean, I was spoiled rotten, spoiled absolutely rotten. I mean, it's what can you do, right? And then in 2010, I was having spent numerous years in the software world. I was looking at doing some programming my own DSP to try and get involved in doing digital room correction. And then I noticed a couple of manufacturers already doing that. And at the time, I had some good headphones and a good playback system for the headphones, but my speakers were just little Logitech desktop computer speakers, just crap, right? And so when I first tried it out on the little crappy desktop speakers, and the saying goes, and even my wife could tell the difference. And so, I mean, she could easily tell the difference. In fact, anybody could tell the difference rather than sounding like a transistor radio, right? It all of a sudden sounded natural. Of course, there's no bass response to the little speakers, but all of a sudden the tone sounded nice and flat as opposed to, that nasally plastic sound that you get out of Logitech speakers with a high frequency peak at like 3 kilohertz kind of thing that drills, it's like a drill in your ear. And so that's when I got back into it. And since then, it's progressed all the way to the point, 10 years later, where I've opened up a business. And, even though my book provides how to step-by-step, and all the articles I've written on the subject also provide step-by-step instructions on how to do it, it's still a very, or can be, technically complex and not obvious when things go wrong. So people will make measurements and don't realize that, one channel's been delayed by 50 milliseconds compared to the other channel, and will go ahead and do a room correction, and then it won't sound any good. It's because the measurement that they took wasn't very good to begin with. And so there was some delay on one channel for whatever reason in the system. There's all sorts of things that can go wrong. There's so many variables. And so the idea of the business that I opened up was to help people, assist people through those tough steps and get them a decent sounding room correction fast. And then they would get the artifacts that I produced. So the actual design artifacts, the target that was used, the frequency-dependent windowing variables, and all this stuff that's bewildering to folks, and give them the artifacts and then some basic training so that they could reproduce what I've done. And then from there, they can make small adjustments or make whatever adjustments they want, if they want. A lot of people have just, been fine with just getting the filters, and they're completely happy with that level of involvement. And so I'm always trying to have an educational component to everything that's involved, because people ask me, well, what if I have to come back and I've changed something, like I've bought different speakers or what have you, and I could say, yeah, you could come back, or I could just simply show you to the point where you can do it. Some people still just come back anyways because they just don't have either the technical skills or don't want the hassle. It's taken me 10 years to get to a place where I can take virtually any speaker in any room, and I can pretty much guarantee that there'll be a dramatic improvement based on the measured frequency response of the before and after. And most people can hear it right away. You can really hear the bass response when every bass note is even. Those things are just like that. So as far as time it takes, some people send me their measurement files, and in a couple of days they're done. They're happy with the filters that they received and just happily listening to music. Others may take a week or two because they want to sit back and listen, and they may get 4 different filters with 4 slightly different frequency responses, and trying to determine which one they like best. It's kind of a funny thing. Some people think that they might need different frequency responses for different genres of music, or different masterings and the like, but generally speaking, I have found and have been using the same filter for every type of music, whether regardless of what genre it is, and also for home theater, so watching movies or even Netflix. And in fact, you can route Netflix through these systems to also give your movie watching the full treatment as well. And so there's a couple of tricks in doing that, because most of the filters that we produce have latency, but there is ways to produce a minimum phase filter and give up a little bit on the time coherence, but still get the nice smooth response, which is way better than nothing. So that's typically in a nutshell. Whether or not which software DSP software you want to use kind of depends on, budget to a certain degree, or if you have a preference. Or I might make a suggestion where one software in your particular situation is much easier to deal with than if it was in a different situation. But the 2 top brands are Accurate and AudioLens. Those are the top guys. Just below that is Dirac. Part of the issue with Dirac, there's a pro and a con. The pro is that they've made it very difficult to mess up. Basically, you're just pressing some wizard control in the software and making measurements, and then using a default correction and listening to it. The con is that there's not much to adjust. And so if you don't happen to like the sound, no matter what target that you're using, you can't shorten or lengthen the amount of correction. You can't turn down the amount of correction either. And so you're stuck with that, and that's the downside. On the freeware side, there is Denise Chavon's DRC open source software, which works quite good, but it's a bit of a do-it-yourself approach. There's a lot of command line stuff involved. And then further down, you get into things like Odyssey, SonarWorks, REW, and or rephase, do-it-yourself techniques there. Those are not really room correction software, but have been adapted to make it useful, but they're definitely not like the full-blown digital room commercial versions of the digital room correction software. Typically, the services fees that I charge are typically for a DSP package, for example, which gets you up to 6 filters over 2 or 3 days or a couple of weeks time frame of working together, is typically $500. Right now, I've got a special on because of the situation that we're in, giving people a price break, so it's about $400 for that. And I don't leave, no one goes away dissatisfied. I do whatever I can to make sure that, you've got the right sound. A lot of people ask, like, well, how can you do this when you're not there in the room? It's pretty easy. If you know enough about acoustics and psychoacoustics and our hearing and what's coming off the speakers and room reflections and all that stuff, there is a pattern to it, and it's pretty similar. Virtually every room's got the same bass problems. They're just at different frequencies based on the room ratios. And then it's a matter of, how lively or dead your room is, and then, personal preference as to how much high frequency energy you want coming at your ears. Those three things are typically what vary the most. And so usually what I do is start off with a frequency response that is more or less the same as your speaker's response, the natural response off your speakers, except it's smoothed out quite a bit. We start there. And then once we find a tonal response, some people like the EBU targets, some people like the Harman target from a flat line from 20 hertz to minus 10 dB at 20 kilohertz, produces a nice flat response, or a nice perceived flat response from our ears, because a flat response in the anechoic chamber does not translate to a flat response in the listening room. So there's a bunch of funky kind of understandings for that. But the customer or the client is, your ears are my ears. And so based on what feedback that you're telling me, I can easily make some adjustments, and usually we get it pretty good fairly quickly. Once we've got a tonal response, then we can adjust how much correction is being applied. So a couple filters to listen to where there's decreasingly less correction, so that people can kind of hear the difference between something that's really tightly controlled versus something that's got a little bit more breathing room to it. And so that's how much dB of correction we want. And then finally we get into things like, well, do folks like a linear phase or a mixed phase kind of filter, which produces a different timing response, even though the frequency response is the same. And so people have preferences over one or the other. And that's the level of detail that we can get into. Generally speaking, though, most people are kind of blown away when they first hear it. They just can't understand, like, how can my system that I know so well sound that much better with these filters? And I think that's where the real benefit is, for people to understand that the room is really doing damage to the sound that you're listening to. And so the more that you can kind of take the room out of the equation or make it work in your favor, all of a sudden it's like, wow, I had no idea that my system was capable of that kind of bass response. It sounds fantastic. And so this is kind of the revelation I've had, is trying to, help out folks that have spent a lot of money on their stereo systems, or really want that sound quality that you would normally hear in a studio, but in their home, but don't want to spend all the money on a build of a new room, or spend all the money on a bunch of acoustic treatments that may or may not do the job of what it intends to do, or just don't want those panels in the room. I mean, I've got panels in my room, and I'm very lucky to have a significant other that is completely understanding. And in fact, I've got some very large industrial speakers in my room, and again, I'm very, very lucky to have someone that's very understanding to have those in my room. But
yeah, no, I thank you for going into that detail. Kind of just so folks know, like, David, Mitch didn't ask to come on so that he could talk about this. I'm sort of forcing him to do that, and I appreciate him going into that level of detail. This is not like a advertisement or anything. I just wanted folks to know, especially at this price point. Like, if he charged $10,000 for the service, then I'd feel a little bit maybe uncomfortable about recommending it. But I think for the value that you're getting and the experience that he brings to this process, this is probably the bargain of the century. Most of the people in the clubs that I know have, at one point or another, spent more than $500 on a power cable or a USB cable, and I absolutely guarantee you that the difference this makes will be many orders of magnitude greater than what you got out of that cable. Not to say that cables are bad, but just the value proposition is going to be completely different than that. So Mitch, I thank you for describing that. The other thing I'd like to point out, some folks have used Dirac or like some of these other tools that come with your home theater processor, where you stick a little lapel mic or whatever in your listening position and hold it in your teeth or whatever, and then the thing makes some noises, and then you push a button and it does some correction. And it works okay. Maybe it helps you set up some delay for some of your speakers so that the time arrival is reasonably close from each speaker, even though the actual distance of the speakers are different to your ears and all that kind of stuff. And that's okay. This is not that solution. This is completely different. Just like I remember I told you before that in the olden days, or, a lot of us have been very reluctant to get into streaming of any kind because the quality just wasn't there. Yeah, it's convenient. The kids are doing it. You can listen to music on your phone and all the rest of that stuff. But is it really ready for my hi-fi listening room? Is it really ready for my primary listening room? And it hasn't been until recently, in my opinion, and that of many others, that streaming has gotten to the point where it matches or exceeds the quality that we're able to get from the venerable compact disc, that it can deliver the level of listening enjoyment and engagement that some of our other sources and our really best systems in our house are able to deliver. And I think this falls into that same category. This level of DSP, this level of room correction and EQ and adjustment, correcting both amplitude and time domain issues in our room, is on a completely different level than those little kind of automated wizard-driven tools that you've used in home theater or other environments. Some of them can be pretty good, and they can help in an environment. I have used Dirac in my home theater system, and we'll go back to that if Emotiva manages to add Dirac back to the processor before I perish. But it's fine there, but it's not on the same, in my experience anyway, it's just not on the same level as this. And then add to that you're potentially bringing somebody in with Mitch's level of experience. So getting, we don't want, obviously, like Mitch said, we don't want just ruler flat response in our room. We want something that's perceptually flat. Well, from what I understand, our ears have kind of evolved over the centuries, and so the human brain kind of can look at the situation that you're in through your eyes, and then your brain uses those visual cues to process what your ears are hearing. And so your brain expects to hear some bass reinforcement when you're in an enclosed space. If you're a caveman and you're standing in a cave, your brain does some processing so that when other people are talking, you can kind of understand what they're saying, even though there's kind of more bass output in their voice. Your brain applies that sort of EQ at a cerebral mental level. That same kind of stuff is going on in your rooms. And so if you don't have more bass output than you do high output in an enclosed space, your brain can't accept it. Your brain's getting those visual cues, and it's not lining up with what it expects. And so ruler flat response is not what we're looking for. As Mitch alluded to, there have been a lot of research. Harman International did a tremendous amount of research, Floyd Toole and a bunch of other people, about kind of what if you put a human being in an enclosed space of certain dimensions and you show them that space and then you play them music, what sounds right to them, what is right, and how do you get a bunch of different people that are good at providing that kind of feedback so that you can in aggregate kind of understand how the human visual and hearing mechanisms work together to kind of understand and perceive the sound that we're hearing. And so what Mitch is doing in building these filters using these tools is to match that up. The other thing is you can't fight the response of the loudspeakers, and you can't fight the response of the room. And so EQ systems that try to like dramatically change what's coming out of the speaker to make them sound completely different are typically gonna fail. You're gonna end up you're just going to end up with some results that are not so great. And so having that level of understanding as well, to take a look at what the loudspeaker's kind of natural response is, and then to smooth things out a little bit, but we're not trying to make your KEF LS50s sound like, Klipschorns or whatever. We're not trying to dramatically change the response of these things. We're just trying to get them to sound and integrate with the room as best they possibly can. Anyway, so it's a fascinating topic. Like I said, I've been exploring it with Mitch's help for the last 3 or 4 years, and he's been doing it for a lot longer. And I think that folks who tend to be more kind of inquisitive and DIY like Mitch's book's a great place to start. There are a lot of resources. He's published a lot of things just for free out there. A lot of other folks have as well. You can go and this can be a hobby all by itself, separate and apart from listening, to explore all of these things. But if you just want to get the best possible sound out of your room, if you feel like your room sounds really, really good, but you're kind of curious now and would like to know what it could sound like if DSP was really, really done well, then I think exploring what Mitch is offering makes a ton of sense. I don't think you'll spend $500 this year or possibly ever on your system and get more results out of it. So sales pitch over, I guess, as far as that goes. Again, this is just from my personal experience. Mitch and I are going to be working on my room as well, even though I've done my room. And Mitch, I haven't sent you my recordings yet just because I've been busy trying to get ready for this talk today. But I'm very curious to see what I can learn from Mitch. As he described an important part of the service he provides as an educational component. So if you're interested, you're not going to walk away from this with just some filters that you shove into your system. You're going to walk away with a deeper understanding of how the stuff works and potentially how to repeat some of those steps on your own later on. I think that's a tremendous benefit as well. And it gives you maybe the capability of adding some of this kind of correction to other rooms in your house. My wife has a pair of desktop speakers as well from Mackie, and they sound okay. But I used Accurate to create filters for those, and now they sound really, really good. John is asking if we can use volume leveling at a track level. John, you can, and some people do, especially if you've got like a playlist of just like all kinds of, especially for background music, I find this to be helpful. Or if you've got a playlist with just all kinds of genres, you've got some EDM mixed up with some string quartets or whatever, and you don't want to be blown away. I generally find that album level volume leveling works best so that I get the relative loudness. If I'm listening to a symphony and there's the softer parts on one track and then the louder movements are on the other tracks, if they're broken down that way, I want the symphony experience from end to end for those relative volume levels across the album to apply and make sense. Ricky Lee Jones has got some crazy album volume levels that was it something Flying Cowboys? I'm not remembering the name, but there's like one track that's got a super loud spot and then everything else is really, really low. And it's nice to be able to appreciate the relative volume levels. But if you're listening for background music or just this kind of shuffle playlist type of deal, even those different levels can be a little bit distracting. So you can switch it over to definitely switch over to track level volume leveling in most kind of software playback. Certainly Roon does. Roon's got an auto setting as well. I have no idea what that does. I don't use it. I think it's better to be intentional and kind of know what you're getting as far as the stuff goes. But it's a good question. Let's see. I have kept Mitch on for a lot longer than I thought, but he was gracious enough to agree to stick around. One of the things I wanted to touch on, just so that people know kind of where to start, I've got endless questions here, and I may answer these kind of separately or offline. But one of the things I wanted to touch on was what microphones you recommend. You talked about an older Dayton UMIK1, I think. I'm not even sure that one's still available. At least I've been having trouble finding it here in the States. What are maybe you can speak to some of the pros and cons of using a full USB mic like the Dayton UMM6 versus an analog mic like the Dayton EMM6. Again, these are calibrated microphones typically that are used for taking measurements. They're not vocal microphones. They're not instrument microphones. Those have a very different purpose and typically intentionally don't have flat response, where these have flat response, but maybe that response is over a more limited dynamic range, or there's some other characteristics of these mics that wouldn't make them great for recording vocals and that kind of stuff, but do make them suitable for measurements. But maybe talk about, and kind of where I'm getting at here is clock source. When we're doing some of these timing measurements between a USB mic and an analog mic that's going into an audio interface like a Focusrite or Motu or something like that.
Yeah, that's a great question, David. And so for sure, just to speak a little bit about the microphones and measurement microphones in general. So these are omnidirectional microphones, meaning that they pick up sound as if it was a 360-degree bubble or sphere. And so the calibration file that they provide, and it's really important to have a calibrated mic. And the reason why I'm saying that is because, we are making frequency response adjustments where even a 1 dB variation is going to make a change in how we perceive the frequency response. And so if the measurement microphone is not calibrated, then we don't know, got no reference to make the adjustment to. And so the whole idea behind a calibrated measurement microphone is that it's ruler flat from 20 to 20 kilohertz. And in fact, some of these microphones, like the really expensive Earthworks microphones, they're flat all the way out to 50 kilohertz, but they're $1,200 mics, number one. And then other microphones that have just a basic calibration file work pretty good, but there is a company called Cross Spectrum Labs in the US. I've forgotten where they're located, but you can find them online. And they provide their own calibration, which is a much finer detail of calibration for the microphone than the typical mini DSP microphone. So the UMIC-1 is a very popular USB microphone from mini DSP. Now, Cross Spectrum Labs buys those and recalibrates, provides you with a higher resolution calibration file, and they also provide at different angles, more different angles for the calibration. So, and they calibrate from 5 hertz to 25 kilohertz, so an absolute full range calibration and more data points in between the actual calibration file. Now, getting to your point, David, about USB clock issues. So those USB microphones, they have their own analog to digital converter inside the microphone and therefore their own clock. And then you've got your DAC and computer, which uses its own clock. And so the issue is that you get what's called clock drift. And so what happens is that if you measure your speaker system and then the time it takes for the whole sweep to go through, so from 20 hertz to 20 kilohertz, may take 5 or 10 seconds, the frequency differentiation between the two clock sources may have drifted a little bit over time, and therefore is going to give you not the best timing measurement, and it'll show up a little bit in the frequency response. Having said that, now software like Accurate and AudioLens and REW, they now have clock drift compensation built in to the measurement software. And so does DIRAC, I should have mentioned that. And so what they do is they take a sweep of the left channel, sweep of the right channel, and then another sweep of the left channel, and then they use a calculation to make sure that there's no drift between the frequency response and the timing response. And so that's relatively new. That's happened over the last couple of years in each one of these software products, because that was a huge problem. It was also a huge problem that they did start at the same time. So not only did you have clock drift, where the frequency kind of changes over time, but you also had start and stop differences. And so what happens is with the UMIC-1, if you didn't have clock drift compensation on, and you took a sweep of the left channel and a sweep of the right channel, the frequency response might look very good, but when you switch to the time domain and look at the step response, you'll see that one started actually maybe a millisecond later than the other one started. And so if you tried to produce a correction on that, all of a sudden you're listening to your stereo and the center image sounds off. It's towards one side of the speaker or the other side of the speaker because of the different start and stop times. These are one of the many kind of tricks or things that you learn over doing it for over and over again, that you run into all these little niggly little problems. And so the good news is that the software, the main software whether it's REW or Accurate or AudioLens that we use, has this clock drift compensation. And so I did a test just a couple of weeks back, and where I took my USB UMIC-1 mic and my good old analog mic that I've had for years, and taped them together so the tips were just about exactly at the same point, put them on the mic stand, and then I took sweeps of each channel, first with the USB mic and then with the analog mic, made sure that everything else stayed exactly the same. The only difference was that I just simply switched microphones. And so I actually took 3 separate measurements, one with the clock drift compensation on, one with it off, and then one with the analog mic. And it turns out that with the clock drift compensation off, you can clearly see that it's a crappy measurement and that the timing's all wrong and the frequency response doesn't look quite right. And then when you put the clock drift compensation on for the USB mic with its own clock in it, all of a sudden it's just as good as if it was with an analog mic. And so I compared the two, and because I've got a tri-amped system, and because of the software I was using, measures the time delay for each component of the tri-amp, so the tweeter, woofer, subs, down to like 0.00 milliseconds, so 2 decimal places. You could read the numbers of the ones with the clock drift with no compensation was way off, and then with the analog mic and the USB mic with clock drift compensation on, the drift was only 0.02 milliseconds. Yes. So it's inconsequential and has no effect. So people can buy USB mics with the software and have no worries about any kind of clock drift or clock compensation issues. And that's really good news, because even though I love analog mics, but you've got to have a mic preamp before you get into an analog to digital conversion. And so that's just another place where things can go
and all
wrong.
That stuff.
The frequency or the phase response of the preamp may not be good. Exactly. Gain structure issues that go with it. And so the USB mic is so simple. It's a plug and play. I don't have to worry about that. And the good news is that it's calibrated already with, if you're using it with REW, it's already calibrated to be at either 77 dB SPL or around that area. So you don't have to actually try and figure out the level that the sweep's coming at as well. So there's all of these little differences, but in the end, now that the software takes care of all of this clock drift compensation, we don't have to worry about it. And so choosing a USB mic is just as good as choosing an analog mic.
In the olden days, the conventional wisdom was for sure that if you're using RU, then probably the USB mic is going to be fine. But if you're using some of these other solutions, you could get yourself into some trouble with the clocks not lining up. But I really appreciate you digging into that. I'm looking to see if we have any other questions on the stream. I have pages and pages of things that I prepared that we're not going to get to. But I think that's okay. I feel like we've had a really good discussion. There's been some good feedback in the channel as well, and the kind of chat section. I think you've talked about kind of what everybody needs to get started. One of those kind of good recommended USB mics. I don't know if you've used the Dayton UMM6. I just got one a little while ago to try out. One of the things that I wanted to point out is that when I first started doing this, I pointed my microphone directly, kind of, I'm not holding my hand right. I pointed my microphone kind of straight at the plane, midway in between the speakers, but kind of straight at them. I found out later on that the calibration curve that I was using was for vertical orientation. And so as a result, there was probably about a 2 or 3 dB cut in the high frequencies of my system, because the microphone is more sensitive to highs when it's pointed at the speaker, so it picked up more, which means that when I compensated for the response, I cut more. So that's just something to kind of be aware of, and I think you make a good point. I'm hoping that the cross-spectrum guys are still alive and around. I haven't heard any response from them when I've sent emails to them, but definitely a good resource. And if we come up with more, then we'll share that stuff out. We are about at the end of our time. I've got 4 o'clock California time. I appreciate everybody who's stuck around, who are joined and kind of watched all of this stuff. I'll do my best to make sure this is available on replay later on in case you want to kind of rewind and watch some of your favorite spots. If I'm successful, the URL will be the same. If not, I'll add it to the comments here. Mitch, I am indebted to you. Thank you so much for joining and for going into so much detail and having such a great discussion. This is, I think it's been amazing for everybody else. It's definitely been amazing for me. And I wish everybody the best. Stay safe during this whole crazy time. I'm hoping that it'll all sort itself out really soon, and we'll be gradually get back to kind of a normal life. In the meantime, make the most out of that audio system. Enjoy it. It's good stress relief. It's good for your health. And make use of all the tools and technology that's available to continue to improve it. The nice thing about this kind of stuff as well is that you can, make improvements to your room correction curve once you've got the basics set up without spending more money. If you're kind of bored with how your system sounds, go back and revisit those curves, retune things up, and it's just like buying another preamp or whatever, except it's kind of free. So pro tip there, if you're somebody who can't be content with your system unless you change it every few months, this will buy you a lot of that without much additional cost. So Mitch, again, thank you very much. I'll clap virtually for everybody else who's on the channel. And I wish everybody else, absolutely, sure. Wish everybody
Thanks
else
a lot, David.
A great weekend. All right. For sure.
Take care, everyone. Cheers. Thanks again, David. Really appreciate it.